Chapter 6, Part 3 of an Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Stephen Reynolds. An Inquiry into the Human Mind on the Principles of Common Sense by Thomas Reid. Chapter 6, Part 3. Section 11. Of our seeing objects erect by inverted images. Another phenomenon which hath perplexed philosophers is our seeing objects erect when it is well known that their images or pictures upon the tunica retina of the eye are inverted. The sagacious Kepler first made the noble discovery that distinct but inverted pictures of visible objects are formed upon the retina by the rays of light coming from the object. The same great philosopher demonstrated from the principles of optics how these pictures are formed, to wit, that the rays coming from any one point of the object, and falling upon the various parts of the pupil, are by the cornea and crystalline refracted so as to meet again in one point of the retina, and there paint the colour of that point of the object from which they come. As the rays from different points of the object cross each other before they come to the retina, the picture they form must be inverted, the upper part of the object being painted upon the lower part of the retina, the right side of the object upon the left of the retina, and so of the other parts. This philosopher thought that we see objects erect by means of these inverted pictures, for this reason, that as the rays from different points of the object cross each other before they fall upon the retina, we conclude that the impulse which we feel upon the lower part of the retina comes from above, and that the impulse which we feel upon the higher part comes from below. Descartes afterwards gave the same solution of this phenomena, and illustrated it by the judgment which we form of the position of objects which we feel with our arms crossed, or with two sticks that cross each other. But we cannot acquiesce in this solution. First, because it supposes our seeing things erect to be a deduction of reason drawn from certain premises, whereas it seems to be an immediate perception. And secondly, because the premises from which all mankind are supposed to draw this conclusion never entered into the minds of the far greater part, but are absolutely unknown to them. We have no feeling of perception of the pictures upon the retina, and as little surely of the position of them. In order to see objects erect, according to the principles of Kepler or Descartes, we must previously know that the rays of light come from the object to the eye in straight lines. We must know that the rays from different points of the object cross one another before they form the picture upon the retina. And lastly, we must know that these pictures are really inverted. Now, although all these things are true, and known to philosophers, yet they are absolutely unknown to the far greatest part of mankind. Nor is it possible that they who are absolutely ignorant of them should reason from them, and build conclusions upon them. Since therefore visible objects appear erect to the ignorant as well as to the learned, this cannot be a conclusion drawn from premises which never entered into the minds of the ignorant. We have indeed had occasion to observe many instances of conclusions drawn either by means of original principle, or by habit from premises which pass through the mind very quickly, and which are never made the objects of reflection. But surely no man will conceive it possible to draw conclusions from premises which never entered into the mind at all. Bishop Berkeley, having justly rejected this solution, gives one founded upon his own principles, wherein he is followed by the judicious Dr. Smith in his Optics, and this we shall next explain and examine. That ingenious writer conceives the ideas of sight to be altogether unlike those of touch, and since the notions we have of an object by these different senses have no similitude, we can learn only by experience how one sense will be affected by what, in a certain manner, affects the other. Figure, position, and even number in tangible objects are ideas of touch, and although there is no similitude between these and the ideas of sight, yet we learn by experience that a triangle affects the sight in such a manner, and that a square affects it in such another manner. Hence we judge that which affects it in the first manner to be a triangle, and that which affects it in the second to be a square. In the same way, finding from experience that an object in an erect position affects the eye in one manner, and the same object in an inverted position affects it in another, we learn to judge by the manner in which the eye is affected, whether the object is erect or inverted. In a word, visible ideas, according to this author, are signs of the tangible, and the mind passeth from the sign to the thing signified, not by means of any similitude between the one and the other, nor by any natural principle, but by having found them constantly conjoined in experience, as the sounds of a language are with the things they signify. So that if the images upon the retina had been always erect, they would have shewn the objects erect, in the manner as they do now that they are inverted. Nay, if the visible idea which we now have from an inverted object had been associated from the beginning with the erect position of that object, it would have signified an erect position, as readily as it now signifies an inverted one. And if the visible appearance of 2 shillings had been found connected from the beginning with the tangible idea of 1 shilling, that appearance would as naturally and readily have signified the unity of the object as now it signifies its duplicity. This opinion is undoubtedly very ingenious, and if it is just, serves to resolve not only the phenomenon now under consideration, but likewise that which we shall next consider, our seeing objects single with 2 eyes. It is evident that in this solution it is supposed that we do not originally, and previous to acquired habits, see things either erect or inverted, of one figure or another, single or double, but learn from experience to judge of their tangible position, figure, and number by certain visible signs. Indeed, it must be acknowledged to be extremely difficult to distinguish the immediate and natural objects of sight from the conclusions which we have been accustomed from infancy to draw from them. Bishop Berkeley was the first that attempted to distinguish the one from the other, and to trace out the boundary that divides them. And if in doing so he hath gone a little to the right hand or to the left, this might be expected in a subject altogether new and of the greatest subtlety. The nature of vision hath received great light from this distinction, and many phenomena in optics, which before appeared altogether unaccountable, have been clearly and distinctly resolved by it. It is natural and almost unavoidable to one who hath made an important discovery in philosophy to carry it a little beyond its sphere, and to apply it to the resolution of phenomena which do not fall within its province. Even the great Newton, when he had discovered the universal law of gravitation, and observed how many of the phenomena of nature depend upon this, and other laws of attraction and repulsion, could not help expressing his conjecture that all the phenomena of the material world depending upon attracting and repelling forces in the particles of matter. And I suspect that the ingenious Bishop of Cloyne, having found so many phenomena of vision reducible to the constant association of the ideas of sight and touch, carried this principle a little beyond its just limits. In order to judge as well as we can whether it is so, let us suppose such a blind man as Dr. Saunderson, having all the knowledge and abilities which a blind man may have, suddenly made to see perfectly. Let us suppose him kept from all opportunities of associating his ideas of sight with those of touch, until the former become a little familiar, and the first surprise occasioned by objects so new being abated, he has time to canvass them, and to compare them in his mind with the notions which he formerly had by touch, and in particular to compare in his mind that visible extension which his eyes present with the extension in length and breadth with which he was before acquainted. We have endeavoured to prove that a blind man may form a notion of the visible extension and figure of bodies from the relation which it bears to their tangible extension and figure. Much more, when this visible extension and figure are presented to his eye, will he be able to compare them with tangible extension and figure, and to perceive that the one has length and breadth as well as the other, that the one may be bounded by lines, either straight or curve, as well as the other. And therefore he will perceive that there may be visible as well as tangible circles, triangles, quadrilateral and multilateral figures. And although the visible figure is coloured and the tangible is not, they may notwithstanding have the same figure, as two objects of touch may have the same figure, although one is hot and the other cold. We have demonstrated that the properties of visible figures differ from those of the plane figures which they represent, but it was observed at the same time that when the object is so small as to be seen distinctly at one view, and is placed directly before the eye, the difference between the visible and the tangible figure is too small to be perceived by the senses. Thus it is true that of every visible triangle, the 3 angles are greater than 2 right angles, whereas in a plane triangle the 3 angles are equal to 2 right angles. But when the visible triangle is small, its 3 edges will be so nearly equal to 2 right angles that the sense cannot discern the difference. In like manner, the circumferences of unequal visible circles are not, but those of plane circles are, in the ratio of their diameters, yet in small visible circles the circumferences are very nearly in the ratio of their diameters, and the diameter bears the same ratio to the circumference as in a plane circle, very nearly. Hence it appears that small visible figures, and such only can be seen distinctly at one view, have not only a resemblance to the plain tangible figures which have the same name, but are to all sense the same. So that if Dr. Saunderson had been made to see, and had attentively viewed the figures of the first book of Euclid, he might by thought and consideration, without touching them, have found out that they were the very figures he was before so well acquainted with by touch. When plane figures are seen obliquely, their visible figure differs more from the tangible, and the representation which is made to the eye of solid figures is still more imperfect, because visible extension hath not 3 but 2 dimensions only. Yet as it cannot be said that an exact picture of a man hath no resemblance to the man, or that a perspective view of a house hath no resemblance of the house, so it cannot be said with any propriety that the visible figure of a man or of a house hath no resemblances of the objects which they represent. Bishop Berkeley therefore proceeds upon a capital mistake, in supposing that there is no resemblance betwixt the extension, figure, and position which we see, and that which we perceive by touch. We may further observe that Bishop Berkeley's system with regard to material things must have made him see this question of the erect appearance of objects in a very different light from that in which it appears to those who do not adopt his system. In his theory of vision he seems indeed to allow that there is an external material world, but he believed that this external world is tangible only, and not visible, and that the visible world, the proper object of sight, is not external but in the mind. If this is supposed, he that affirms that he sees things erect and not inverted, affirms that there is a top and a bottom, a right and a left in the mind. Now I confess I am not so well acquainted with the topography of the mind as to be able to affix a meaning to these words when applied to it. We shall therefore allow that if visible objects were not external, but existed only in the mind, they could have no figure or position, or extension, and that it would be absurd to affirm that they are seen either erect or inverted, or that there is any resemblance between them and the objects of touch. But when we propose the question why objects are seen erect and not inverted, we take it for granted that we are not in Bishop Berkeley's ideal world, but in that world which men, who yield to the dictates of common sense, believe themselves to inhabit. We take it for granted that the objects both of sight and touch are external, and have a certain figure and a certain position with regard to one another and with regard to our bodies, whether we perceive it or not. When I hold my walking cane upright in my hand and look at it, I take it for granted that I see and handle the same individual object. When I say that I feel it erect, my meaning is that I feel the head directed from the horizon, and the point directed towards it. And when I say that I see it erect, I mean that I see it with the head directed from the horizon, and the point towards it. I conceive the horizon as a fixed object, both of sight and touch, with relation to which objects are said to be high or low, erect or inverted. And when the question is asked why I see the object erect and not inverted, it is the same as if you should ask why I see it in that position which it really hath, or why the eye shows the real position of objects, and doth not show them in an inverted position, as they are seen by a common astronomical telescope, or as their pictures are seen upon the retina of an eye when it is dissected. Section 12. The same subject continued. It is impossible to give a satisfactory answer to this question, otherwise than by pointing out the laws of nature which take place in vision, for by these the phenomena of vision must be regulated. Therefore I answer, first, that by a law of nature the rays of light proceed from every point of the object to the pupil of the eye in straight lines. Secondly, that by the laws of nature the rays coming from any one point of the object to the various parts of the pupil are so refracted as to meet again in one point of the retina, and the rays from different points of the object first crossing each other and then proceeding to as many different points of the retina, form an inverted picture of the object. So far the principles of optics carry us, and experience further assures us that if there is no such picture upon the retina, there is no vision, and that such as the picture on the retina is, such is the appearance of the object in colour and figure, distinctness or indistinctness, brightness or faintness. It is evident, therefore, that the pictures upon the retina are, by the laws of nature, a mean of vision, but in what way they accomplish their end we are totally ignorant. Philosophers conceive that the impression made upon the retina by the rays of light is communicated to the optic nerve, and by the optic nerve conveyed to some part of the brain, by them called the sensorium, and that the impression thus conveyed to the sensorium is immediately perceived by the mind which is supposed to reside there. But we know nothing of the seat of the soul, and we are so far from perceiving immediately what is transacted in the brain, that of all parts of the human body we know least about it. It is indeed very probable that the optic nerve is an instrument of vision no less necessary than the retina, and that some impression is made upon it by means of the picture on the retina. But of what kind this impression is, we know nothing. There is not the least probability that there is any picture or image of the object either in the optic nerve or brain. The pictures on the retina are formed by the rays of light, and whether we suppose with some that their impulse upon the retina causes some vibration of the fibres of the optic nerve, or with others that it gives motion to some subtle fluid contained in the nerve, neither that vibration nor this motion can resemble the visible object which is presented to the mind. Nor is there any probability that the mind perceives the pictures upon the retina. These pictures are no more objects of our perception than the brain is, or the optic nerve. No man ever saw the pictures in his own eye, nor indeed the pictures in the eye of another, until it was taken out of the head and duly prepared. It is very strange that philosophers of all ages should have agreed in this notion, that the images of external objects are conveyed by the organs of sense to the brain, and are there perceived by the mind. Nothing can be more unphilosophical. For first, this notion hath no foundation in fact and observation. Of all the organs of sense, the eye only, as far as we can discover, forms any kind of image of its object, and the images formed by the eye are not in the brain, but only in the bottom of the eye, nor are they at all perceived or felt by the mind. Secondly, it is as difficult to conceive how the mind perceives images on the brain, as how it perceives things more distant. If any man will show how the mind may perceive images in the brain, I will undertake to show how it may perceive the most distant objects. For if we give eyes to the mind, to perceive what has transacted at home in its dark chamber, why may we not make these eyes a little longer sighted? And then we shall have no occasion for that unphilosophical fiction of images in the brain. In a word, the manner and mechanism of the mind's perception is quite beyond our comprehension, and this way of explaining it by images in the brain seems to be founded upon very gross notions of the mind and its operation, as if the supposed images in the brain by a kind of contact formed similar impressions or images of objects upon the mind, of which impressions it is supposed to be conscious. We have endeavoured to show throughout the course of this inquiry that the impressions made upon the mind by means of the five senses have not the least resemblance to the objects of sense, and therefore, as we see no shadow of evidence that there are any such images in the brain, so we see no purpose, in philosophy, that the supposition of them can answer. Since the picture upon the retina, therefore, is neither itself seen by the mind, nor produces any impression upon the brain or sensorium, which is seen by the mind, nor makes any impression upon the mind that resembles the object, it may still be asked how this picture upon the retina causes vision. Before we answer this question, it is proper to observe that in the operations of the mind, as well as in those of bodies, we must often be satisfied with knowing that certain things are connected and invariably follow one another without being able to discover the chain that goes between them. It is to such connections that we give the name of laws of nature, and when we say that one thing produces another by a law of nature, this signifies no more but that the one thing, which we call in popular language the cause, is constantly and invariably followed by another, which we call the effect, and that we know not how they are connected. Thus we see it is a fact that bodies gravitate towards bodies, and that this gravitation is regulated by certain mathematical proportions, according to the distances of the bodies from each other, and their quantities of matter. Being unable to discover the cause of this gravitation, and presuming that it is the immediate operation either of the author of nature, or of some subordinate cause which we have not hitherto been able to reach, we call it a law of nature. If any philosopher should hereafter be so happy as to discover the cause of gravitation, this can only be done by discovering some more general law of nature, of which the gravitation of bodies is a necessary consequence. In every chain of natural causes, the highest link is a primary law of nature, and the highest link which we can trace by just induction is either this primary law of nature or a necessary consequence of it. To trace out the laws of nature by induction from the phenomena of nature is all that true philosophy aims at, and all that it can ever reach. There are laws of nature by which the operations of the mind are regulated. There are also laws of nature that govern the material system, and as the latter are the ultimate conclusions which the human faculties can reach in the philosophy of bodies, so the former are the ultimate conclusions we can reach in the philosophy of minds. To return, therefore, to the question above proposed, we may see, from what hath been just now observed, that it amounts to this: by what law of nature is a picture upon the retina the mean or occasion of my seeing an external object of the same figure and colour, in a contrary position and in a certain direction from the eye? It will without doubt be allowed that I see the whole object in the same manner, and by the same law by which I see any one point of it. Now I know it to be a fact that in direct vision I see every point of the object in the direction of the right line that passeth from the centre of the eye to that point of the object. And I know likewise from optics that the ray of light that comes to the centre of my eye passes on to the retina in the same direction. Hence it appears to be a fact that every point of the object is seen in the direction of a right line passing from the picture of that point on the retina through the centre of the eye. As this is a fact that holds universally and invariably, it must either be a law of nature, or the necessary consequence of some more general law of nature. And according to the just rules of philosophizing, we may hold it for a law of nature, until some more general law be discovered, whereof it is a necessary consequence, which I suspect can never be done. Thus we see that the phenomena of vision lead us by the hand to a law of nature, or a law of our constitution, of which law our seeing objects erect by inverted images is a necessary consequence. For it necessarily follows from the law we have mentioned that the object whose picture is lowest on the retina must be seen in the highest direction from the eye, and that the object whose picture is on the right of the retina must be seen on the left, so that if the pictures had been erect in the retina, we should have seen the object inverted. My chief intention in handling this question was to point out this law of nature, which, as it is a part of the constitution of the human mind, belongs properly to the subject of this inquiry. For this reason I shall make some further remarks upon it, after doing justice to the ingenious Dr. Portersfield, who long ago in the Medical Essays, or more lately in his Treatise of the Eye, pointed out as a primary law of our nature that a visible object appears in the direction of a right line perpendicular to the retina at that point where its image is painted. If lines drawn from the centre of the eye to all parts of the retina be perpendicular to it, as they must be very nearly, this coincides with the law we have mentioned, and is the same in other words. In order, therefore, that we may have a more distinct notion of this law of our constitution, we may observe 1. That we can give no reason why the retina is, of all parts of the body, the only one on which pictures made by the rays of light cause vision, and therefore we must resolve this solely into a law of our constitution. We may form such pictures by means of optical glasses upon the hand, or upon any other part of the body, but they are not felt, nor do they produce anything like vision. A picture upon the retina is as little felt as one upon the hand, but it produces vision, for no other reason that we know, but because it is destined by the wisdom of nature to this purpose. The vibrations of the air strike upon the eye, the palate, and the olfactory membrane, with the same force as upon the membrana tympani of the ear. The impression they make upon the last produces the sensation of sound, but their impression upon any of the former produce no sensation at all. This may be extended to all of the senses, whereof each hath its peculiar law, according to which the impressions made upon the organ of that sense produce sensations or perceptions in the mind that cannot be produced by impressions made upon any other organ. 2. We may observe that the law of perception by the different senses are very different, not only in respect of the nature of the objects perceived by them, but likewise in respect of the notices they give us of the distance and situation of the object. In all of them the object is conceived to be external, and to have real existence, independent of our perception. But in one, the distance, figure, and situation of the object are all presented to the mind. In another, the figure and situation, but not the distance. And in others, neither figure, situations, nor distance. In vain do we attempt to account for these varieties in the manner of perception by the different senses, from principles of anatomy or natural philosophy. They must at last be resolved into the will of our Maker, who intended that our powers of perception should have certain limits, and adapted the organs of perception and the laws of nature by which they operate to his wise purpose. When we hear an unusual sound, the sensation indeed is in the mind, but we know that there is something external that produced this sound. At the same time, our hearing does not inform us whether the sounding body is near or at a distance, in this direction or that, and therefore we look round to discover it. If any new phenomenon appears in the heavens, we see exactly its colour, its apparent place, magnitude, and figure, but we see not its distance. It may be in the atmosphere, it may be among the planets, or it may be in the sphere of the fixed stars, for anything the eye can determine. The testimony of the senses of touch reaches only to objects that are contiguous to the organ, but with regard to them is more precise and determinate. When we feel a body with our hand, we know the figure, distance, and position of it, as well as whether it is rough or smooth, hard or soft, hot or cold. The sensations of touch, of seeing, and hearing are all in the mind and can have no existence but when they are perceived. How do they all constantly and invariably suggest the conception and belief of external objects, which exist whether they are perceived or not? No philosopher can give any other answer to this, but that such is the constitution of our nature. How do we know that the object of touch is at the finger's end and nowhere else? That the object of sight is in such a direction from the eye, and in no other, but may be at any distance? And that the object of hearing may be at any distance and in any direction? Not by custom, surely, not by reasoning or comparing ideas, but by the constitution of our nature. How do we perceive visible objects in the direction of right lines perpendicular to that part of the retina on which the rays strike, while we do not perceive the object of hearing in lines perpendicular to the membrana tympani, upon which the vibrations of the air strike? Because such are the laws of nature. But do we know the parts of our bodies affected by particular pains, not by experience or by reasoning, but by the constitution of nature? The sensation of pain is no doubt in the mind, and cannot be said to have any relation from its own nature to any part of the body. But this sensation by our constitution gives a perception of some particular part of the body, whose disorder causes the uneasy sensation. If it were not so, a man who never before felt either the gout or the toothache, when he is first seized with the gout in his toe, might mistake it for a toothache. Every sense, therefore, hath its peculiar laws and limits by the constitution of our nature. And one of the laws of sight is that we always see an object in the direction of a right line passing from its image on the retina through the centre of the eye. 3. Perhaps some readers will imagine that it is easier, and will answer the purpose as well, to conceive a law of nature by which we shall always see objects in the place in which they are, and in their true position, without having recourse to images on the retina or to the optical centre of the eye. To this I answer that nothing can be a law of nature which is contrary to fact. The laws of nature are the most general facts we can discover in the operations of nature. Like other facts, they are not to be hit upon by a happy conjecture, but justly deduced from observation. Like other general facts, they are not to be drawn from a few particulars, but from a copious, patient, and cautious induction. That we see things always in their true place and position is not fact, and therefore it can be no law of nature. In a plain mirror I see myself and other things in places very different from those they really occupy, and so it happens in every instance wherein the rays coming from the objects are either reflected or refracted before falling upon the eye. Those who know anything of optics know that in all such cases the object is seen in the direction of a line passing from the centre of the eye to the point where the rays were last reflected or refracted, and that upon this all the powers of the telescope and microscope depend. Shall we say then that it is a law of nature that the object is seen in the direction which the rays have when they fall on the eye, or rather in the direction contrary to that of the rays when they fall upon the eye? No, this is not true, and therefore it is no law of nature. For the rays from any one point of the object come to all parts of the pupil, and therefore must have different directions. But we see the object only in one of these directions, to wit, in the direction of the rays that came to the centre of the eye. And this holds true even when the rays that should pass through the centre are stopped, and the object is seen by rays that pass at a distance from the centre. Perhaps it is still to be imagined that although we are not made so as to see objects always in their true place, nor so as to see them precisely in the direction of the rays when they fall upon the cornea, yet we may be so made as to see the object in the direction which the rays have when they fall upon the retina, after they have undergone all their refractions in the eye, that is, in the direction in which the rays pass from the crystalline to the retina. But neither is this true, and consequently it is no law of our constitution. In order to see that it is not true, we must conceive all the rays that pass from the crystalline to one point of the retina as forming a small cone, whose base is upon the back of the crystalline, and whose vertex is a point of the retina. It is evident that the rays which form the picture in this point have various directions, even after they pass the crystalline, yet the object is seen only in one of these directions, to wit, in the direction of the rays that come from the centre of the eye. Nor is this owing to any particular virtue in the central rays, or in the centre itself, for the central rays may be stopped. When they are stopped, the image will be formed upon the same point of the retina as before, by rays that are not central, nor have the same direction which the central rays had, and in this case the object is seen in the same direction as before, although there are now no rays coming in that direction. From this induction we conclude that our seeing an object in that particular direction in which we do see it, is not owing to any law of nature by which we are made to see it in the direction of the rays, either before their refractions in the eye, or after, but to a law of our nature by which we see the object in the direction of the right line that passeth from the picture of the object upon the retina to the centre of the eye. The facts upon which I ground this induction are taken from some curious experiments of Scheiner in his Fundament Optik, quoted by Dr. Porterfield, and confirmed by his experience. I have also repeated these experiments, and found them to answer. As they are easily made, and tend to illustrate and confirm the law of nature I have mentioned, I shall recite them as briefly and distinctly as I can. Experiment 1. Let a very small object, such as the head of a pin, well illuminated, be fixed at such a distance from the eye as to be beyond the nearest limit, and within the farthest limit of distinct vision. For a young eye, not near-sighted, the object may be placed at the distance of 18 inches. Let the eye be kept steadily in one place, and take a distinct view of the object. We know from the principles of optics that the rays from any one point of this object, whether they pass through the centre of the eye, or at any distance from the centre which the breadth of the pupil will permit, do all unite again in one point of the retina. We know also that these rays have different directions, both before they fall upon the eye, and after they pass through the crystalline. Now we can see the object by any one small parcel of these rays, excluding the rest, by looking through a small pinhole in a card. Moving this pinhole over the various parts of the pupil, we can see the object, first by the rays that pass above the centre of the eye, then by the central rays, then by the rays that pass below the centre, and in like manner by the rays that pass on the right and left of the centre. Thus we view this object successively by rays that are central, and by rays that are not central, by rays that have different directions, and are variously inclined to each other, both when they fall upon the cornea and when they fall upon the retina, but always by rays which fall upon the same point of the retina. And what is the event? It is this, that the object is seen in the same individual direction, whether seen by all these rays together, or by any one parcel of them. Experiment 2. Let the object above mentioned be now placed within the nearest limit of distinct vision, that is, for an eye that is not near-sighted, at the distance of 4 or 5 inches. We know that in this case the rays coming from one point of the object do not meet in one point of the retina, but spread over a small circular spot of it, the central rays occupying the centre of this circle, the rays that pass above the centre occupying the upper part of the circular spot, and so of the rest. And we know that the object is in this case seen confused, every point of it being seen, not in one but in various directions. To remedy this confusion, we look at the object through the pinhole, and while we move the pinhole over the various parts of the pupil, the object does not keep its place, but seems to move in a contrary direction. It is here to be observed that when the pinhole is carried upwards over the pupil, the picture of the object is carried upwards upon the retina, and the object at the same time seems to move downwards, so as to be always in the right line passing from the picture through the centre of the eye. It is likewise to be observed that the rays which form the upper and lower pictures upon the retina do not cross each other as in ordinary vision, yet still the higher picture shews the object lower, and the lower picture shews the object higher, in the same manner as when the rays cross each other. Whence we may observe, by the way, that this phenomenon of our seeing objects in a position contrary to that of their pictures upon the retina, does not depend upon the crossing of the rays, as Kepler and Descartes conceived. Experiment 3. Other things remaining as in the last experiment, make 3 pin-holes in a straight line so near that the rays coming from the object through all the holes may enter the pupil at the same time. In this case we have a very curious phenomenon, for the object is seen triple with one eye, and if you make more holes within the breadth of the pupil, you will see as many objects as there are holes. However, we shall suppose them only 3, one on the right, one in the middle, and one on the left, in which case you see 3 objects standing in a line from right to left. It is here to be observed that there are 3 pictures on the retina, that on the left being formed by the rays which pass on the left of the eye's centre, the middle picture being formed by the central rays, and the right-hand picture by the rays which pass on the right of the eye's centre. It is farther to be observed that the object which appears on the right is not that which is seen through the hole on the right, but that which is seen through the hole on the left, and in like manner the left-hand object is seen through the hole on the right, as is easily proved by covering the holes successively. So that whatever is the direction of the rays which form the right-hand and left-hand pictures, still the right-hand picture shews a left-hand object, and the left-hand picture shows a right-hand object. Experiment 4. It is easy to see how the 2 last experiments may be varied by placing the object beyond the farthest limit of distinct vision. In order to make this experiment, I looked at a candle at the distance of 10 feet, and put the eye of my spectacles behind the card, that the rays from the same point of the object might meet and cross each other before they reached the retina. In this case, as in the former, the candle was seen in triple through the 3 pinholes, but the candle on the right was seen through the hole on the right, and, on the contrary, the left-hand candle was seen through the hole on the left. In this experiment, it is evident from the principles of optics, that the rays forming the several pictures on the retina, cross each other a little before they reach the retina, and therefore the left-hand picture is formed by the rays which pass through the hole on the right, so that the position of the pictures is contrary to that of the holes by which they are formed, and therefore it is also contrary to that of their objects, as we have found it to be in the former experiments. These experiments exhibit several uncommon phenomena that regard the apparent place and the direction of visible objects from the eye. phenomena that seem to be most contrary to the common rules of vision. When we look at the same time through three holes that are in a right line, and at certain distances from each other, we expect that the objects seen through them should really be, and should appear to be, at a distance from each other. Yet by the first experiment we may through three such holes see the same object and the same point of that object, and through all the three it appears in the same individual place and direction. When the rays of light come from the object in right lines to the eye, without any reflection, inflection, or refraction, we expect that the object should appear in its real and proper direction from the eye, and so it commonly does. But in the second, third, and fourth experiments, we see the object in a direction which is not its true and real direction from the eye, although the rays come from the object to the eye without any inflection, reflection, or refraction. When both the object and the eye are fixed without the least motion, and the medium unchanged, we expect that the object should appear to rest and keep the same place. Yet in the second and fourth experiments, when both the eye and the object are at rest, and the medium unchanged, we make the object appear to move upwards or downwards, or in any direction we please. When we look at the same time, and with the same eye, through holes that stand in a line from right to left, we expect that the object seen through the left-hand hole should appear on the left, and the object seen through the right-hand hole should appear on the right. Yet in the third experiment we find the direct contrary. Although many instances occur in seeing the same object double with two eyes, we always expect that it should appear single when seen only by one eye. Yet in the second and fourth experiment we have instances wherein the same object may appear double, triple, or quadruple to one eye, without the help of a polyhedron or multiplying glass. All these extraordinary phenomena regarding the direction of visible objects from the eye, as well as those that are common and ordinary, lead us to the law of nature which I have mentioned, and are the necessary consequences of it. And as there is no probability that we shall ever be able to give a reason why pictures upon the retina make us see external objects, any more than pictures upon the hand or upon the cheek, or that we shall ever be able to give a reason why we see the object in the direction of a line passing from its picture through the centre of the eye rather than in any other direction, I am therefore apt to look upon this law as a primary law of our constitution. To prevent being misunderstood, I beg the reader to observe that I do not mean to affirm that the picture upon the retina will make us see an object in the direction mentioned, or in any direction, unless the optic nerve, and the other more immediate instruments of vision, be sound and perform their function. We know not well what is the office of the optic nerve, nor in what manner it performs that office, but that it hath some part in the faculty of seeing seems to be certain, because in an amaurosis, which is believed to be a disorder of the optic nerve, the pictures of the retina are clear and distinct, and yet there is no vision. We know still less of the use and function of the choroid membranes, but it seems likewise to be necessary to vision, for it is well known that pictures upon that part of the retina, where it is not covered by the choroid, I mean at the entrance of the optic nerve, produce no vision any more than a picture upon the hand. We acknowledge, therefore, that the retina is not the last and most immediate instrument of the mind in vision. There are other material organs whose operation is necessary to seeing, even after the pictures upon the retina are formed. If ever we come to know the structure and use of the choroid membrane, the optic nerve, and the brain, and what impressions are made upon them by means of the pictures on the retina, some more links in the chain may be brought within our view, and a more general law of vision discovered. But while we know so little of the nature and office of these more immediate instruments of vision, it seems to be impossible to trace its laws beyond the pictures upon the retina. Neither do I pretend to say that there may not be diseases of the eye, or accidents which may occasion our seeing objects in a direction somewhat different from that mentioned above. I shall beg leave to mention one instance of this kind that concerns myself. In May 1761, being occupied in making an exact meridian in order to observe the transit of Venus, I rashly directed to the sun by my right eye the cross hairs of a small telescope. I had often done the like in my younger days with impunity, but I suffered by it at last, which I mention as a warning to others. I soon observed a remarkable dimness in that eye, and for many weeks when I was in the dark or shut my eyes, there appeared before the right eye a lucid spot which trembled much like the image of the sun seen by reflection from water. This appearance grew fainter and less frequent by degrees, so that now there are seldom any remains of it. But some other very sensible effects of this hurt still remain. For, first, the sight of the right eye continues to be more dim than that of the left. Secondly, the nearest limit of distinct vision is more remote in the right eye than in the other, although before the time mentioned they were equal in both these respects, as I had found by many trials. But thirdly, what I chiefly intended to mention is that a straight line in some circumstances appears to the right eye to have a curvature in it. Thus, when I look upon a music book, and shutting my left eye direct the right to a point of the middle line of the 5 which compose the staff of music, the middle line appears dim, indeed at the point to which the eye is directed, but straight at the same time the 2 lines above it, and the 2 below it, appear to be bent outwards, and to be more distant from each other, and from the middle line, than at any other parts of the staff, to which the eye is not directed. Fourthly, although I have repeated this experiment times innumerable within these 16 months, I do not find that custom and experience takes away this appearance of curvature in straight lines. Lastly, this appearance of curvature is perceptible when I look with the right eye only, but not when I look with both eyes. Yet I see better with both eyes together than even with the left eye alone. I have related this fact minutely as it is, without regard to any hypothesis, because I think such uncommon facts deserve to be recorded. I shall leave it to others to conjecture the cause of this appearance. To me it seems most probable that a small part of the retina towards the centre is shrunk, and that thereby the contiguous parts are drawn nearer to the centre and to one another than they were before, and that objects whose images fall upon these parts appear at the distance from each other which corresponds not to the interval of the parts in their present preternatural contractions, but to their interval in their natural and sound state. Section 13. Of seeing objects single with 2 eyes. Another phenomenon of vision which deserves attention is our seeing objects single with 2 eyes. There are 2 pictures of the object, one on each retina, and each picture by itself makes us see an object in a certain direction from the eye. Yet both together commonly make us see only one object. All the accounts or solutions of this phenomenon given by anatomists and philosophers seem to be unsatisfactory. I shall pass over the opinions of Garin, of Gassendus, of Baptista, Porta, and Rohaut. The reader may see these examined and refuted by Dr. Porterfield. I shall examine Dr. Porterfield's own opinion, Bishop Berkeley's, and some others. But it will be necessary first to ascertain the facts, for if we mistake the phenomena of single and double vision, it is 10 to 1 but this mistake will lead us wrong in assigning the causes. This likewise we ought carefully to attend to, which is acknowledged in theory by all who have any true judgment or just taste in inquiries of this nature, but is very often overlooked in practice, namely, that in the solution of natural phenomena, all the length that the human faculties can carry us is only this, that from particular phenomena we may by induction trace out general phenomena, of which all the particular ones are necessary consequences. And when we have arrived at the most general phenomena we can reach, there we must stop. If it is asked why such a body gravitates towards the earth, all the answer that can be given is, because all bodies gravitate towards the earth. This is resolving a particular phenomenon into a general one. If it should again be asked, why do all bodies gravitate towards the earth, we can give no other solution of this phenomenon, but that all bodies whatsoever gravitate towards each other. This is resolving a general phenomenon into a more general one. If it should be asked why all bodies gravitate to one another, we cannot tell. But if we could tell, it could only be by resolving our universal gravitation of bodies into some other phenomenon still more general, and of which the gravitation of all bodies is a particular instance. The most general phenomena we can reach are what we call laws of nature, so that the laws of nature are nothing else but the most general facts relating to the operations of nature, which include a great many particular facts under them. And if in any case we should give the name of a law of nature to a general phenomenon, which human industry shall afterwards trace to one more general, there is no great harm done. The most general assumes the name of a law of nature when it is discovered, and the less general is contained and comprehended by it. Having premised these things, we proceed to consider the phenomena of single and double vision, in order to discover some general principle to which they all lead, and of which they are the necessary consequences. If we can discover any such general principle, it must either be a law of nature, or the necessary consequence of some law of nature, and its authority will be equal, whether it is the first or the last. 1. We find that when the eyes are sound and perfect, and the axis of both directed to one point, an object placed in that point is seen single. And here we observe that in this case the two pictures which show the object single are in the centres of the retina. When two pictures of a small object are formed upon points of the retina, if they show the object single, we shall for the sake of perspicuity call such two points of the retina corresponding points, and where the object is seen double, we shall call the points of the retina on which the pictures are formed, points that do not correspond. Now in this first phenomenon it is evident that the two centres of the retina are corresponding points. 2. Supposing the same things as in the last phenomenon, other objects at the same distance from the eye as that to which their axes are directed do also appear single. Thus, if I direct my eyes to a candle placed at the distance of 10 feet, and while I look at this candle, another stands at the same distance from my eyes within the field of vision, I can, while I look at the first candle, attend to the appearance which the second makes to the eye, and I find that in this case it always appears single. It is here to be observed that the pictures of the second candle do not fall upon the centre of the retina, but they both fall upon the same side of the centres, that is, both to the right or both to the left, and both are at the same distance from its centres. This might be easily demonstrated from the principles of optics. Hence it appears that in this second phenomenon of single vision, the corresponding points are points of the two retinae, which are similarly situate with respect to the two centres, being both upon the same side of the centre, and at the same distance from it. It appears likewise from this phenomenon that every point in one retina corresponds with that which is similarly situate in the other. 3. Supposing still the same things, objects which are much nearer to the eyes, or much more distant from them, than that to which the two eyes are directed, appear double. Thus, if the candle is placed at the distance of 10 feet, and I hold my finger at arm's length between my eyes and the candle, when I look at the candle I see my finger double, and when I look at my finger I see the candle double, and the same thing happens with regard to all other objects at like distances, which falls within the sphere of vision. In this phenomenon it is evident to those who understand the principles of optics that the pictures of the objects, which are seen double, do not fall upon points of the retinae which are similarly situate, but that the pictures of the objects seen single do fall upon points similarly situate. Whence we infer that as the points of the two retinae, which are similarly situate with regard to the centres, do correspond, so those which are dissimilarly situate do not correspond. 4. It is to be observed that although in such cases as are mentioned, in the last phenomenon, we have been accustomed from infancy to see objects double which we know to be single, yet custom and experience of the unity of the object never take away this appearance of duplicity. 5. It may, however, be remarked that the custom of attending to visible appearances has a considerable effect, and makes the phenomenon of double vision to be more or less observed and remembered. Thus you may find a man that can say with good conscience that he never saw things double all his life. Yet this very man, put in the situation above mentioned, with his finger between him and the candle, and desired to attend to the appearance of the object which he does not look at, will upon the first trial see the candle double when he looks at his finger, and his finger double when he looks at the candle. Does he now see otherwise than he saw before? No, surely, but he now attends to what he never attended to before. The same double appearance of an object hath been 1,000 times presented to his eye before now, but he did not attend to it, and so it is as little an object of his reflection and memory as if it had never happened. When we look at an object, the circumjacent objects may be seen at the same time, although more obscurely and indistinctly, for the eye hath a considerable field of vision which it takes in at once. But we attend only to the object we look at. The other objects which fall within the field of vision are not attended to, and therefore are as if they were not seen. If any of them draws out attention, it naturally draws the eyes at the same time, for in the common course of life the eyes always follow the attention. Or if at any time in a reverie they are separated from it, we hardly at that time see what is directly before us. Hence we may see the reason why the man we are speaking of thinks that he never before saw an object double. When he looks at any object he sees it single, and takes no notice of the other visible objects at the time, whether they appear single or double. If any of them draws his attention, it draws his eyes at the same time, and as soon as the eyes are turned towards it, it appears single. But in order to see things double, at least in order to have any reflection or remembrance that he did so, it is necessary that he should look at one object, and at the same time attend to the faint appearance of other objects, which are within the same field of vision. This is a practice which perhaps he never used, nor attempted, and therefore he does not recollect that ever he saw an object double. But when he is put upon giving his attention, he immediately sees objects double in the same manner, and with the very same circumstances, as they who have been accustomed, for the greatest part of their lives, to give this attention. There are many phenomena of a similar nature which show that the mind may not attend to, and thereby, in some sort, not perceive, objects that strike the senses. I had occasion to mention several instances of this in the second chapter, and I have been assured by persons of the best skill in music, that in hearing a tune upon the harpsichord, when they give attention to the treble, they do not hear the bass, and when they attend to the bass, they do not perceive the air of the treble. Some persons are so near-sighted that in reading they hold the book to one eye, while the other is directed to other objects. Such persons acquire the habit of attending, in this case, to the objects of one eye, while they give no attention to those of the other. 6. It is observable that in all cases wherein we see an object double, the two appearances have a certain position with regard to one another, and a certain apparent angular distance. This apparent distance is greater or less in different circumstances, but in the same circumstances it is always the same, not only to the same but to different persons. Thus in the experiment above mentioned, if 20 different persons, who see perfectly with both eyes, shall place their finger and the candle at the distances above expressed, and hold their heads upright, looking at the finger they will see 2 candles, one on the right, another on the left. That which is seen on the right is seen by the right eye, and that which is seen on the left by the left eye, and they will see them at the same apparent distance from each other. If again they look at the candle they will see 2 fingers, one on the right and the other on the left, and all will see them at the same apparent distance, the finger towards the left being seen by the right eye, and the other by the left. If the head is laid horizontally to one side, other circumstances remaining the same, one appearance of the object seen double will be directly above the other. In a word, vary the circumstances as you please, and the appearances are varied to all the spectators in one and the same manner. 7. Having made many experiments in order to ascertain the apparent distance of the two appearances of an object seen double, I have found that in all cases this apparent distance is proportioned to the distance between the point of the retina where the picture is made in one eye, and the point which is situated similarly to that on which the picture is made on the other eye, so that as the apparent distance of two objects seen with one eye is proportioned to the arch of the retina which lies between their pictures. In like manner, when an object is seen double with the two eyes, the apparent distance of the two appearances is proportioned to the arc of either retina, which lies between the picture in that retina and the point corresponding to that of the picture in the other retina. 8. As in certain circumstances we invariably see one object appear double, so in others we as invariably see two objects unite into one, and in appearance lose their duplicity. This is evident in the appearance of the binocular telescope, and the same thing happens when any two similar tubes are applied to the two eyes in parallel direction, for in this case we see only one tube, and if two shillings are placed at the extremities of the two tubes, one exactly in the axis of one eye, and the other in the axis of the other eye, we shall see but one shilling. If two pieces of coin, or other bodies of different colour and of different figure, be properly placed in the two axes of the eye, and at the extremities of the tubes, we shall see both bodies in one and the same place, each as it were spread over the other without hiding it, and the colour will be that which is compounded of the two colours. 9. From these phenomena, and from all the trials I have been able to make, it appears evidently that in perfect human eyes the centres of the two retinae correspond and harmonize with each other, and that every other point in one retina doth correspond and harmonize with the point which is similarly situate in the other, in such manner that pictures falling on the corresponding points of the two retinae shew only one object, even when there are really two, and pictures falling upon other points of the retinae which do not correspond show us two visible appearances, although there be but one object. So that pictures upon corresponding points of the two retinae present the same appearance to the mind as if they had both fallen upon the same point of one retina, and pictures upon points of the two retinae which do not correspond present to the mind the same apparent distance and position of two objects, as if one of those pictures was carried to the point corresponding to it in the other retina. This relation and sympathy between corresponding points of the two retinae I do not advance as an hypothesis, but as a general fact or phenomenon of vision. All the phenomena before mentioned of single or double vision lead to it, and are necessary consequences of it. It holds true invariably in all perfect human eyes, as far as I am able to collect from innumerable trials of various kinds made upon my own eyes, and many made by others at my desire. Many of the hypotheses that have been contrived to resolve the phenomena of single and double vision suppose this general fact, while their authors were not aware of it. Sir Isaac Newton, who was too judicious a philosopher and too accurate an observer to have offered even a conjecture which did not tally with the facts that had fallen under his observation, proposes a query with respect to the cause of it. Optics, query 15. The judicious Dr. Smith, in his Optics 1:137, hath confirmed the truth of this general phenomenon from his own experience, not only as to the apparent unity of objects whose pictures fall upon the corresponding points of the retinae, but also as to the apparent distance of the two appearances of the same object when seen double. This general phenomenon appears therefore to be founded upon a very full induction, which is all the evidence we can have for a fact of this nature. Before we make an end of this subject, it will be proper to inquire first, whether those animals whose eyes have an adverse position on their heads, and look contrary ways, have such corresponding points in their retinae. Secondly, what is the position of the corresponding points in imperfect human eyes, I mean in those that squint, and in the last place, whether this harmony of the corresponding points in the retinae be natural and original, or the effect of custom, and if it is original, whether it can be accounted for by any of the laws of nature already discovered, or whether it is itself to be looked upon as a law of nature and a part of the human constitution. End of Chapter 6, Part 3. Recording by Stephen Reynolds, Durham, Connecticut. Chapter 6, Part 4 of an Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Stephen Reynolds. An Inquiry into the Human Mind on the Principles of Common Sense by Thomas Reid. Chapter 6, Part 4. Section 14. Of the Laws of Vision in Brute Animals. It is the intention of nature, in giving eyes to animals, that they may perceive the situation of visible objects, or the direction in which they are placed. It is probable, therefore, that in ordinary cases, every animal, whether it has many eyes or few, whether of one structure or of another, sees objects single and in their true and proper direction. And since there is a prodigious variety in the structure and motions, and the number of eyes in different animals and insects, it is probable that the laws by which vision is regulated are not the same in all, but various, adapted to the eyes which nature hath given them. Mankind naturally turn their eyes always the same way, so that the axis of the two eyes meet in one point. They naturally attend to or look at that object only which is placed in the point where the axes meet, and whether the object be more or less distant, the configuration of the eye is adapted to the distance of the object, so as to form a distinct picture of it. When we use our eyes in this natural way, the two pictures of the object we look at are formed upon the centers of the two retinae, and the two pictures of any contiguous object are formed upon the points of the retinae, which are similarly situate with regard to the centers. Therefore, in order to our seeing objects single and in their proper direction with two eyes, it is sufficient that we be so constituted that objects whose pictures are formed upon the centers of the two retinae, or upon points similarly situated with regard to these centers, shall be seen in the same visible place. And this is the constitution which nature hath actually given to human eyes. When we distort our eyes from their parallel direction, which is an unnatural motion, but may be learned by practice, or when we direct the axes of the two eyes at one point, and at the same time direct our attention to some visible object much nearer, or much more distant than that point, which is also unnatural, yet may be learned. In these cases, and in these only, we see one object double, or two objects confounded in one. In these cases, the two pictures of the same object are formed upon the points of the retinae which are not similarly situate, and so the object is seen double. Or the two pictures of different objects are formed upon points of the retinae which are similarly situate, and so the two objects are seen confounded in one place. Thus it appears that the laws of vision in the human constitution are wisely adapted to the natural use of human eyes, but not to that use of them which is unnatural. We see objects truly when we use our eyes in the natural way, but have false appearances presented to us when we use them in a way that is unnatural. We may reasonably think that the case is the same with other animals. But is it not unreasonable to think that those animals which naturally turn one eye towards one object, and another eye towards another object, must thereby have such false appearances presented to them as we have when we do so against nature? Many animals have their eyes by nature placed adverse and immovable, the axis of the two eyes being always directed to opposite points. Do objects painted on the centers of the two retinae appear to such animals as they do to human eyes, in one and the same visible place? I think it is highly probable that they do not, and that they appear as they really are in opposite places. If we judge from analogy in this case, it will lead us to think that there is a certain correspondence between points of the two retinae in such animals, but of a different kind from that which we have found in human eyes. The center of one retina will correspond with the center of the other, in such manner that the objects whose pictures are formed upon these corresponding points shall appear not to be in the same place as in human eyes, but in opposite places. And in the same manner will the superior part of one retina correspond with the inferior part of the other, and the anterior part of one with the posterior part of the other. Some animals by nature turn their eyes with equal facility, either the same way or different ways, as we turn our hands and arms. Have such animals corresponding points in their retinae, and points which do not correspond as the humankind has? I think it is probable that they have not, because such a constitution in them could serve no other purpose but to exhibit false appearances. If we judge from analogy, it will lead us to think that as such animals move their eyes in a manner similar to that in which we move our arms, they have an immediate and natural perception of the direction they give to their eyes, as we have of the direction we give to our arms, and perceive the situation of visible objects by their eyes in a manner similar to that in which we perceive the situation of tangible objects with our hands. We cannot teach brute animals to use their eyes in any other way than in which nature hath taught them, nor can we teach them to communicate to us the appearances which visible objects make to them, either in ordinary or in extraordinary cases. We have not therefore the same means of discovering the laws of vision in them as in our own kind, but must satisfy ourselves with probable conjectures. And what we have said upon this subject is chiefly intended to shew that animals to which nature hath given eyes differing in their number, in their position, and in their natural motions, may very probably be subjected to different laws of vision, adapted to the peculiarities of their organs of vision. Section 15. Squinting considered hypothetically. Whether there be corresponding points in the retinae of those who have an involuntary squint, and if there are, whether they be situate in the same manner as in those who have no squint, are not questions of mere curiosity. They are of real importance to the physician who attempts the cure of a squint, and to the patient who submits to the cure. After so much has been said of the strabismus or squint, both by medical and by optical writers, one might expect to find an abundance of facts for determining these questions. Yet I confess I have been disappointed in this expectation, after taking some pains both to make observations and to collect those which have been made by others. Nor will this appear very strange, if we consider that to make the observations which are necessary for determining these questions, knowledge of the principles of optics and of the laws of vision must concur with opportunities rarely to be met with. Of those who squint, the far greater part have no distinct vision with one eye. When this is the case, it is impossible, and indeed of no importance, to determine the situation of the corresponding points. When both eyes are good, they commonly differ so much in their direction that the same object cannot be seen by both at the same time, and in this case it will be very difficult to determine the situation of the corresponding points, for such persons will probably attend only to the objects of one eye, and the objects of the other will be as little regarded as if they were not seen. We have before observed that when we look at a near object and attend to it, we do not perceive the double appearances of more distant objects, even when they are in the same direction, and are presented to the eye at the same time. It is probable that a squinting person, when he attends to the objects of one eye, will in like manner have his attention totally diverted from the objects of the other, and that he will perceive them as little as we perceive the double appearances of objects when we use our eyes in the natural way. Such a person, therefore, unless he is so much a philosopher as to have acquired the habit of attending very accurately to the visible appearances of objects, and even of objects which he does not look at, will not be able to give any light to the question now under consideration. It is very probable that hares, rabbits, birds, and fishes, whose eyes are fixed in an adverse position, have the natural faculty of attending at the same time to visible objects placed in different and even in contrary directions, because without this faculty they could not have those advantages from the contrary direction of their eyes, which nature seems to have intended. But it is not probable that those who squint have any such natural faculty, because we find no such faculty in the rest of the species. We naturally attend to the objects placed in the point where the axes of the two eyes meet, and to them only. To give attention to an object in a different direction is unnatural, and not to be learned without pains and practice. A very convincing proof of this may be drawn from a fact well known to philosophers. When one eye is shut, there is a certain space within the field of vision where we can see nothing at all, the space which is directly opposed to that part of the bottom of the eye where the optic nerve enters. This defect of sight in one part of the eye is common to all human eyes, and hath been so from the beginning of the world. Yet it was never known until the sagacity of the Abbé Mariotte discovered it in the last century. And now when it is known, it cannot be perceived but by means of some particular experiments which require care and attention to make them succeed. What is the reason that so remarkable a defect of sight, common to all mankind, was so long unknown, and is now perceived with so much difficulty? It is surely this, that the defect is at some distance from the axis of the eye, and consequently in a part of the field of vision to which we never attend naturally, and to which we cannot attend at all without the aid of some particular circumstances. From what we have said, it appears that to determine the situation of the corresponding points in the eyes of those who squint is impossible, if they do not see distinctly with both eyes, and that it will be very difficult unless the two eyes differ so little in their direction that the same object may be seen with both at the same time. Such patients I apprehend are rare. At least there are very few of them with whom I have had the fortune to meet, and therefore for the assistance of those who may have happier opportunities and inclination to make the proper use of them, we shall consider the case of squinting hypothetically, pointing out the proper articles of inquiry, the observations that are wanted, and the conclusion that may be drawn from them. 1. It ought to be inquired whether the squinting person sees equally well with both eyes, and if there be a defect in one, the nature and degree of that defect ought to be remarked. The experiments by which this may be done are so obvious that I need not mention them, but I would advise the observer to make the proper experiments, and not to rely upon the testimony of the patient, because I have found many instances both of persons that squinted, and others, who were found upon trial to have a great defect in the sight of one eye, although they were never aware of it before. In all the following articles it is supposed that the patient sees with both eyes so well as to be able to read with either when the other is covered. 2. It ought to be inquired whether when one eye is covered the other is turned directly to the object. This ought to be tried in both eyes successively. By this observation, as a touchstone, we may try the hypothesis concerning squinting, invented by M. Delia and adopted by Boerhaave and many others of the medical faculty. The hypothesis is that in one eye of a squinting person the greatest sensibility and the most distinct vision is not, as in other men, in the centre of the retina, but upon one side of the centre, and that he turns the axis of this eye aside from the object in order that the picture of the object might fall upon the most sensible part of the retina, and thereby give the most distinct vision. If this is the cause of squinting, the squinting eye will be turned aside from the object when the other eye is covered, as well as when it is not. A trial so easy to be made never was made for more than 40 years, but the hypothesis was very generally received. So prone are men to invent hypotheses, and so backward to examine them by facts. At last Dr. Joren, having made the trial, found that persons who squint turn the axis of the squinting eye directly to the object, when the other eye is so covered. This fact is confirmed by Dr. Porterfield, and I have found it verified in all the instances that have fallen under my observation. 3. It ought to be inquired whether the axes of the two eyes follow one another, so as to have always the same inclination, or make the same angle when the person looks to the right or to the left, upward or downward, or straight forward. By this observation we may judge whether a squint is owing to any defect in the muscles which move the eye, as some have supposed. In the following articles we suppose that the inclination of the axes of the eyes is found to be always the same. 4. It ought to be inquired whether the person that squints sees an object single or double. If he sees the object double, and if the two appearances have an angular distance equal to the angle which the axes of his eyes make with each other, it may be concluded that he hath corresponding points in the retinae of his eyes, and that they have the same situation as in those who have no squint. If the two appearances should have an angular distance, which is always the same, but manifestly greater or less than the angle contained under the optic axes, this would indicate corresponding points in the retinae whose situation is not the same as in those who have no squint. But it is difficult to judge accurately of the angle which the optic axes make. A squint too small to be perceived may occasion double vision of others, for if we speak strictly, every person squints more or less, whose optic axes do not meet exactly in the object which he looks at. Thus, if a man can only bring the axes of his eyes to be parallel, but cannot make them converge in the least, he must have a small squint in looking at near objects, and will see them double while he sees very distant objects single. Again, if the optic axes always converge so as to meet 8 or 10 feet before the face at farthest, such a person will see near objects single, but when he looks at very distant objects he will squint a little and see them double. An instance of this kind is related by Agullonius in his Optics, who says that he has seen a young man to whom near objects appeared single, but distant objects appeared double. Dr. Briggs, in his Nova Visionis Theoria, having collected the author's several instances of double vision, quotes this from Agullonius as the most wonderful and unaccountable of all, insomuch that he suspects some imposition on the part of the young man, but to those who understand the laws of which single and double vision are regulated, it appears to be the natural effect of a very small squint. Double vision may always be owing to a small squint, when the two appearances are seen at small angular distances, although no squint was observed, and I do not remember any instances of double vision recorded by authors wherein any account is given of the angular distance of the appearances. In almost all the instances of double vision, there is reason to suspect a squint or distortion of the eyes from the concomitant circumstances, which we find to be one or the other of the following: the approach of death, or of a deliquium, excessive drinking or other intemperance, violent headache, blistering the head, smoking tobacco, blows or wounds in the head. In all these cases it is reasonable to suspect the distortion of the eyes, either from spasm or paralysis in the muscles that move them. But although it be probable that there is always a squint, greater or less, where there is double vision, yet it is certain that there is not double vision always where there is a squint. I know no instance of double vision that continued for life, or even for a great number of years. We shall therefore suppose in the following articles that the squinting person sees objects single. 5. The next inquiry then ought to be, whether the object is seen with both eyes at the same time, or only with the eye whose axis is directed to it. It hath been taken for granted by the writers upon the strabismus before Dr. Joren, that those who squint commonly see objects single with both eyes at the same time. But I know not one fact advanced by any writer which proves it. Dr. Joren is of a contrary opinion, and as it is of consequence, so it is very easy to determine this point in particular instances, by this obvious experiment. While the person that squints looks steadily at an object, let the observer carefully remark the direction of both his eyes, and observe their motions, and let an opaque body be interposed between the object and the two eyes successively. If the patient, notwithstanding this interposition, and without changing the direction of the eyes, continues to see the object all the time, it may be concluded that he saw it with both eyes at once. But if the interposition of the body between one eye and the object makes it disappear, then we may be certain that it was seen by that eye only. In the two following articles we shall suppose the first to happen, according to the common hypothesis. 6. Upon this supposition it ought to be inquired whether the patient sees an object double in those circumstances wherein it appears double to them who have no squint. Let him, for instance, place a candle at the distance of 10 feet, and holding his finger at arm's length between him and the candle, let him observe when he looks at the candle whether he sees his finger with both eyes, and whether he sees it single or double. And when he looks at his finger, let him observe whether he sees the candle with both eyes, and whether single or double. By this observation it may be determined whether to this patient the phenomena of double as well as of single vision are the same as to them who have no squint. If they are not the same, if he sees the objects single with two eyes not only in the cases wherein they appear single, but in those also wherein they appear double to other men, the conclusion to be drawn from this supposition is that his single vision does not arise from corresponding points in the retinae of his eyes, and that the laws of vision are not the same in him as in the rest of mankind. 7. If, on the other hand, he sees objects double in those cases wherein they appear double to others, the conclusion must be that he hath corresponding points in the retinae of his eyes, but unnaturally situate, and their situation may be thus determined. When he looks at an object having the axis of one eye directed to it, and the axis of the other turned aside from it, let us suppose a right line to pass from the object through the centre of the diverging eye. We shall, for the sake of perspicuity, call this right line the natural axis of the eye, and it will make an angle with the real axis greater or less according as his squint is greater or less. We shall also call that point of the retina in which the natural axis cuts it the natural centre of the retina, which will be more or less distant from the real centre, according as the squint is greater or less. Having premised these definitions, it will be evident to those who understand the principles of optics that in this person the natural centre of one retina corresponds with the real centre of the other, in the very same manner as the two real centres correspond in perfect eyes, and that the points similarly situate with regard to the real centre in one retina, and the natural centre in the other, do likewise correspond, in the same manner as the points similarly situate with regard to the two real centres correspond in perfect eyes. If it is true, as has been commonly affirmed, that one who squints sees an object with both eyes at the same time, and yet sees it single, the squint will most probably be such as we have described in this article. And we may further conclude that if a person affected with such a squint as we have supposed, could be brought to the habit of looking straight, his sight would thereby be greatly hurt, for he would then see everything double, which he saw with both eyes at the same time, and objects distant from one another would appear to be confounded together. His eyes are made for squinting, as much as those of other men are made for looking straight, and his sight would be no less injured by looking straight than that of another man by squinting. He can never see perfectly when he does not squint, unless the corresponding points of his eyes should by custom change their place, but how small the probability of this is will appear in the 17th section. Those of the medical faculty who attempt the cure of a squint would do well to consider whether it is attended with such symptoms as are above described. If it is, the cure would be worse than the malady, for everyone will readily acknowledge that it is better to put up with the deformity of a squint than to purchase the cure by the loss of perfect and distinct vision. 8. We shall now return to Dr. Joren's hypothesis, and suppose that our patient, when he saw objects single notwithstanding his squint, was found upon trial to have seen them only with one eye. We would advise such a patient to endeavour by repeated efforts to lessen his squint, and to bring the axes of his eyes nearer to a parallel direction. We have naturally the power of making small variations in the inclination of the optic axes, and this power may be greatly increased by exercise. In the ordinary and natural use of our eyes, we can direct their axes to a fixed star. In this case they must be parallel. We can direct them also to an object 6 inches distant from the eye, and in this case the axes must make an angle of 15 or 20 degrees. We see young people in their frolics learn to squint, making their eyes converge or diverge, when they will, to a very considerable degree. Why should it be more difficult for a squinting person to learn to look straight when he pleases? If once by an effort of his will he can but lessen his squint, frequent practice will make it easy to lessen it, and will daily increase his power, so that if he begins this practice in youth and perseveres in it, he may probably after some time learn to direct both his eyes to one object. When he hath acquired this power, it will be no difficult matter to determine by proper observations whether the centres of the retinae, and other points similarly situate with regard to the centres, correspond as in other men. 9. Let us now suppose that he finds this to be the case, and that he sees an object single with both eyes, when the axes of both are directed to it. It will then concern him to acquire the habit of looking straight, as he hath got the power, because he will thereby not only remove a deformity, but improve his sight, and I conceive this habit, like all others, may be got by frequent exercise. He may practise before a mirror when alone, and in company he ought to have those about him who will observe and admonish him when he squints. 10. What is supposed in the 9th article is not merely imaginary. It is really the case of some squinting persons, as will appear in the next section. Therefore it ought further to be inquired how it comes to pass that such a person sees an object which he looks at only with one eye when both are open. In order to answer this question, it may be observed first, whether when he looks at an object the diverging eye is not drawn so close to the nose that it can have no distinct images, or secondly, whether the pupil of the diverging eye is not covered wholly or in part by the upper eyelid. Dr. Joren observed instances of these cases in persons that squinted, and assigns them as causes of their seeing the object only with one eye. Thirdly, it may be observed whether the diverging eye is not so directed that the picture of the object falls upon that part of the retina where the optic nerve enters, and where there is no vision. This will probably happen in a squint wherein the axes of the eyes converge so as to meet about 6 inches before the nose. 11. In the last place, it ought to be inquired whether such a person hath any distinct vision at all with the diverging eye at the time he is looking at an object with the other. It may seem very improbable that he should be able to read with the diverging eye when the other is covered, and yet when both are open have no distinct vision with it at all. But this perhaps will not appear so improbable if the following considerations are duly attended to. Let us suppose that one who saw perfectly gets, by a blow on the head or some other accident, a permanent and involuntary squint. According to the laws of vision, he will see objects double, and will see objects distant from one another confounded together. But such vision being very disagreeable, as well as inconvenient, he will do everything in his power to remedy it. For alleviating such distresses, nature often teaches men wonderful experiments, which the sagacity of a philosopher would be unable to discover. Every accidental motion, every direction or conformation of his eyes, which lessens the evil, will be agreeable. It will be repeated until it be learned to perfection, and become habitual even without thought or design. Now, in this case, what disturbs the sight of one eye is the sight of the other, and all the disagreeable appearances in vision would cease if the light of one eye was extinct. The sight of one eye will become more distinct and more agreeable in the same proportion as that of the other becomes faint and indistinct. It may therefore be expected that every habit will by degrees be acquired which tends to destroy distinct vision in one eye, while it preserves it in the other. These habits will be greatly facilitated if one eye was at first better than the other, for in that case the best eye will always be directed to the object which he intends to look at, and every habit will be acquired which tends to hinder his seeing at all, or seeing it distinctly by the other at the same time. I shall mention one or two habits that may probably be acquired in such a case. Perhaps there are others which we cannot so easily conjecture. First, by a small increase or diminution of his squint, he may bring it to correspond with one or other of the cases mentioned in the last article. Secondly, the diverging eye may be brought to such a conformation as to be extremely short-sighted, and consequently to have no distinct vision of objects at a distance. I knew this to be the case of one person that squinted, but cannot say whether the short-sightedness of the diverging eye was original or acquired by habit. We see, therefore, that one who squints, and originally saw objects double by reason of that squint, may acquire such habits that when he looks at an object he shall see it only with one eye. Nay, he may acquire such habits that when he looks at an object with his best eye, he shall have no distinct vision with the other at all. Whether this is really the case, being unable to determine in the instances that have fallen under my observation, I shall leave to future inquiry. I have endeavoured in the foregoing article to delineate such a process as is proper in observing the phenomena of squinting. I know well by experience that this process appears more easy in theory than it will be found to be in practice, and that in order to carry it on with success, some qualifications of mind are necessary in the patient, which are not always to be met with. But if those who have proper opportunities and inclination to observe such phenomena attend duly to this process, they may be able to furnish facts less vague and uninstructive than those we meet with, even in authors of reputation. By such facts vain theories may be exploded, and our knowledge of the laws of nature, which regard the noblest of our senses, enlarged. Section 16. Facts related to squinting. Having considered the phenomena of squinting hypothetically, and their connection with corresponding points in the retinae, I shall now mention the facts I have had occasion to observe myself, or have met with in authors that can give any light to this subject. Having examined above 20 persons that squinted, I found in all of them a defect in the sight of one eye. 4 only had so much of distinct vision in the weak eye as to be able to read with it when the other was covered. The rest saw nothing at all distinctly with one eye. Dr. Porterfield says that this is generally the case of people that squint, and I suspect it is so more generally than is commonly imagined. Dr. Jurin, in a very judicious dissertation upon squinting, printed in Dr. Smith's Optics, observes that those who squint and see objects with both eyes never see the same object with both eyes at the same time, that when one eye is directed straight forward to an object, the other is drawn so close to the nose that the object cannot at all be seen by it, the images being too oblique and too indistinct to affect the eye. In some squinting persons he observed the diverging eye drawn under the upper eyelid, while the other was directed to the object. From these observations he concludes that the eye is thus distorted not for the sake of seeing better with it, but rather to avoid seeing at all with it as much as possible. From all the observations he had made, he was satisfied that there is nothing peculiar in the structure of a squinting eye, that the fault is only in its wrong direction, and that this wrong direction is got by habit. Therefore he proposes that method of cure which we have described in the 8th and 9th articles of the last section. He tells us that he had attempted a cure after this method upon a young gentleman with promising hopes of success, but was interrupted by his falling ill of the smallpox, of which he died. It were to be wished that Dr. Jurin had acquainted us whether he ever brought the young man to direct the axes of both eyes to the same object, and whether in that case he saw the object single and saw it with both eyes, and that he had likewise acquainted us whether he saw objects double when his squint was diminished. But as to these facts he is silent. I wished long for an opportunity of trying Dr. Jurin's method of curing a squint, without finding one, having always upon examination discovered so great a defect in the sight of one eye of the patient as discouraged the attempt. But I have lately found 3 young gentlemen, of whom I am hopeful this method may have success, if they have patience and perseverance in using it. 2 of them are brothers, and before I had access to examine them, had been practising this method by the direction of their tutor, with much success, that the elder looks straight when he is upon his guard. The younger can direct both his eyes to one object, but they soon return to their usual squint. A 3rd young gentleman, who had never heard of this method before, by a few days' practice was able to direct both his eyes to one object, but could not keep them long in that direction. All the 3 agree in this, that when both eyes are directed to one object, they see it and the adjacent objects single. But when they squint, they see objects sometimes single and sometimes double. I observed of all the 3 that when they squinted most, that is, in the way they had been accustomed to, the axes of their eyes converged so as to meet 5 or 6 inches before the nose. It is probable that in this case the picture of the object in the diverging eye must fall upon that part of the retina where the optic nerve enters, and therefore the object could not be seen by that eye. All the 3 have some defect in the sight of one eye, which none of them knew until I put them upon making trials, and when they squint the best eye is always directed to the object, and the weak eye is that which diverges from it. But when the best eye is covered, the weak eye is turned directly to the object. Whether this defect of sight in one eye be the effect of its having been long disused, as it must have been when they squinted, or whether some original defect in one eye might be the occasion of their squinting, time may discover. The 2 brothers have found the sight of the weak eye improved by using to read with it, while the other is covered. The elder can read an ordinary print with the weak eye. The other, as well as the 3rd gentleman, can only read large print with the weak eye. I have met with one other person only who squinted, and yet could read large print with the weak eye. He is a young man, whose eyes are both tender and weak-sighted, but the left much weaker than the right. When he looks at any object, he always directs the right eye to it, and then the left is turned toward the nose, so much that it is impossible for him to see the same object with both eyes at the same time. When the right eye is covered, he turns the left directly to the object, but he sees it indistinctly, and as if it had a mist about it. I made several experiments, some of them in the company and with the assistance of an ingenious physician, in order to discover whether objects that were in the axes of the 2 eyes were seen in one place confounded together, as in those who have no involuntary squint. The object placed in the axes of the weak eye was a lighted candle, at the distance of 8 or 10 feet. Before the other eye was placed a printed book, at such a distance as he could read upon it. He said that while he read upon the book, he saw the candle, but very faintly, and from what we could learn, these 2 objects did not appear in one place, but had all that angular distance in appearance which they had in reality. If this was really the case, the conclusion to be drawn from it is, that the corresponding points in his eyes are not situate in the same manner as in other men, and that if he could be brought to direct both eyes to one object, he would see it double. But considering that the young man had never been accustomed to observations of this kind, and that the sight of one eye was so imperfect, I do not pretend to draw this conclusion with certainty from this single instance. All that can be inferred from these facts is that of 4 persons who squint, 3 appear to have nothing preternatural in the structure of their eyes. The centres of the retinae, and the points similarly situate with regard to the centres, do certainly correspond in the same manner as in other men, so that if they can be brought to the habit of directing their eyes right to an object, they will not only remove a deformity, but improve their sight. With regard to the 4th, the case is dubious, with some probability of a deviation from the usual course of nature in the situation of the corresponding points of his eyes. Section 17. Of the effect of custom in seeing objects single. It appears from the phenomena of single and double vision, recited in section 13, that our seeing an object single with 2 eyes depends upon these 2 things. First, upon that mutual correspondence of certain points of the retina which we have often described. Secondly, upon the 2 eyes being directed to the object so accurately that the 2 images of it fall upon corresponding points. These 2 things must concur in order to our seeing an object single with 2 eyes, and as far as they depend upon custom, so far only can single vision depend upon custom. With regard to the second, that is, the accurate direction of both eyes to the object, I think it must be acknowledged that this is only learned by custom. Nature hath wisely ordained the eyes to move in such a manner that their axes shall always be nearly parallel, but hath left it in our power to vary their inclination a little, according to the distance of the object we look at. Without this power, objects would appear single at one particular distance only, and at distances much less or much greater, would always appear double. The wisdom of nature is conspicuous in giving us this power, and no less conspicuous in making the extent of it exactly adequate to the end. The parallelism of the eyes in general is therefore the work of nature, but that precise and accurate direction, which must be varied according to the distance of the object, is the effect of custom. The power which nature hath left us of varying the inclination of the optic axes a little, is turned into a habit of giving them always that inclination which is adapted to the distance of the object. But it may be asked, what gives rise to this habit? The only answer that can be given to this question is, that it is found necessary to perfect and distinct vision. A man who hath lost the sight of one eye very often loses the habit of directing it exactly to the object he looks at, because that habit is no longer of use to him. And if he should recover the sight of his eye, he would recover this habit by finding it useful. No part of the human constitution is more admirable than that whereby we acquire habits which are found useful without any design or intention. Children must see imperfectly at first, but by using their eyes they learn to use them in the best manner, and acquire without intending it the habits necessary for that purpose. Every man becomes most expert in that kind of vision which is most useful to him in his particular profession and manner of life. A miniature painter or an engraver sees very near objects better than a sailor, but the sailor sees very distant objects much better than they. A person that is short-sighted, in looking at distant objects, gets the habit of contracting the aperture of his eyes by almost closing his eyelids. Why? For no other reason but because this makes him see the object more distinct. In like manner, the reason why every man acquires the habit of directing both eyes accurately to the object must be because thereby he sees it more perfectly and distinctly. It remains to be considered whether that correspondence between certain points of the retinae, which is likewise necessary to single vision, be the effect of custom, or an original property of human eyes. A strong argument for its being an original property may be drawn from the habit just now mentioned, of directing the eyes accurately to an object. This habit is got by our finding it necessary to perfect and distinct vision. But why is it necessary? For no other reason but this, because thereby the two images of the object, falling upon corresponding points, the eyes assist each other in vision, and the object is seen better by both together than it could be by one. But when the eyes are not accurately directed, the two images of an object fall upon points that do not correspond, whereby the sight of one eye disturbs the sight of the other, and the object is seen more indistinctly with both eyes than it would be with one. Whence it is reasonable to conclude that this correspondence of certain points of the retinae is prior to the habits we acquire in vision, and consequently is natural and original. We have all acquired the habit of directing our eyes always in a particular manner, which causes single vision. Now, if nature hath ordained that we should have single vision only when our eyes are thus directed, there is an obvious reason why all mankind should agree in the habit of directing them in this manner. But if single vision is the effect of custom, any other habit of directing the eyes would have answered the purpose, and no account can be given why this particular habit should be so universal. And it must appear very strange that no one instance hath been found of a person who had acquired the habit of seeing objects single with both eyes, while they were directed in any other manner. The judicious Dr. Smith, in his excellent System of Optics, maintains the contrary opinion, and offers some reasonings and facts in proof of it. He agrees with Bishop Berkeley in attributing it entirely to custom, that we see objects single with two eyes, as well as that we see objects erect by inverted images. Having considered Bishop Berkeley's reasoning in the 11th section, we shall now beg leave to make some remarks on what Dr. Smith hath said upon this subject, with the respect due to an author to whom the world owes, not only many valuable discoveries of his own, but those of the brightest mathematical genius of this age, which, with great labour, he generously redeemed from oblivion. He observes that the question, why we see objects single with two eyes, is of the same sort with this, why we hear sounds single with two ears, and that the same answer must serve both. The inference intended to be drawn from this observation is, that as the second of these phenomena is the effect of custom, so likewise is the first. Now I humbly conceive that the questions are not so much of the same sort, that the same answer must serve for both, and moreover that our hearing single with two ears is not the effect of custom. Two or more visible objects, although perfectly similar and seen at the very same time, may be distinguished by their visible places, but two sounds, perfectly similar and heard at the same time, cannot be distinguished, for from the nature of sound, the sensations they occasion must coalesce in one and lose all distinction. If therefore it is asked why we hear sounds single with two ears, I answer, not from custom, but because two sounds which are perfectly like and synchronous have nothing by which they can be distinguished. But will this answer fit the other question? I think not. The object makes an appearance to each eye, as the sound makes an impression upon each ear, so far the two senses agree. But the visible appearances may be distinguished by place, when perfectly like in other respects. The sounds cannot be thus distinguished, and herein the two senses differ. Indeed, if the two appearances have the same visible place, they are in that case as incapable of distinction as the sounds were, and we see the object single. But when they have not the same visible place, they are perfectly distinguishable, and we see the object double. We see the object single only when the eyes are directed in one particular manner, while there are many other ways of directing them within the sphere of our power by which we see the object double. Dr. Smith justly attributes to custom that well-known fallacy in feeling, whereby a button pressed with two opposite sides of two continuous fingers laid across it is felt double. I agree with him that the cause of this appearance is that those opposite sides of the fingers have never been used to feel the same object, but two different objects at the same time. And I beg leave to add that as custom produces this phenomenon, so a contrary custom destroys it. for if a man frequently accustoms himself to feel the buttons with his fingers across it, it will at last be felt single, as I have found by experience. It may be taken for a general rule that things which are produced by custom may be undone or changed by disuse, or by a contrary custom. On the other hand, it is a strong argument that an effect is not owing to custom, but to the constitution of nature, when a contrary custom, long continued, is found neither to change nor weaken it. I take this to be the best rule by which we can determine the question presently under consideration. I shall therefore mention two facts brought by Dr. Smith to prove that the corresponding points of the retinae have been changed by custom, and then I shall mention some facts tending to prove that there are corresponding points of the retinae of the eyes originally, and that custom produces no change in them. One fact related upon the authority of Martin Folkes, Esquire, who was informed by Dr. Hepburn of Lymm, that the Reverend Mr. Foster of Clinchwharton, in that neighbourhood having been blind for some years of a gutta serena, was restored to sight by salivation, and that upon his first beginning to see, all objects appeared to him double, but afterwards the two appearances approached by degrees, he came at last to see single and as distinctly as he did before he was blind. Upon this case I observe first that it does not prove any change in the corresponding points of the eyes, unless we suppose, what is not affirmed, that Mr. Foster directed his eyes to the object at first, when he saw double, with the same accuracy and in the same manner that he did afterwards when he saw single. Secondly, if we should suppose this, no account can be given why at first the two appearances should be seen at one certain angular distance rather than another, or why this angular distance should gradually decrease until at last the appearances coincided. How could this effect be produced by custom? But thirdly, every circumstance of this case may be accounted for on the supposition that Mr. Foster had corresponding points in the retinae of his eyes from the time he began to see, and that custom made no change with regard to them. We need only further suppose, what is common in such cases, that by some years' blindness he had lost the habit of directing his eyes accurately to an object, and that he gradually recovered this habit when he came to see. The second fact mentioned by Dr. Smith is taken from Mr. Chelsden's Anatomy, and is this: a gentleman who from a blow on the head had one eye distorted, found every object appear double, but by degrees the most familiar ones became single, and in time all objects became so without any amendment of the distortion. I observe here that it is not said that the two appearances gradually approached and at last united, without any amendment of the distortion. This would indeed have been a decisive proof of a change in the corresponding points of the retinae, and yet of such a change as could not be accounted for from custom. But this is not said, and if it had been observed, a circumstance so remarkable would have been mentioned by Mr. Chelsden, as it was in the other case by Mr. Hepburn. We may therefore take it for granted that one of the appearances vanished by degrees, without approaching to the other, and this I conceive might happen several ways. First, the sight of the distorted eye might gradually decay by the hurt, so that appearances presented by that eye would gradually vanish. Secondly, a small and unperceived change in the manner of directing the eyes might occasion his not seeing the object with the distorted eye, as appears from section 15, article 10. Thirdly, by acquiring the habit of directing one and the same eye always to the object, the faint and oblique appearance presented by the other eye might be so little attended to when it became familiar as not to be perceived. One of these causes, or more of them concurring, might produce the effect mentioned, without any change of the corresponding points of the eyes. For these reasons, the facts mentioned by Dr. Smith, although curious, seem not to be decisive. The following facts ought to be put in the opposite scale. First, in the famous case of the young gentleman couched by Mr. Chelsden, after having had cataracts on both his eyes until he was 13 years of age, it appears that he saw objects single from the time he began to see with both eyes. Mr. Chelsden's words are, And now, being lately couched of his other eye, he says that objects at first appeared large to this eye, but not so large as they did at first to the other. And looking upon the same object with both eyes, he thought it looked about twice as large as with the first couched eye only, but not double, that we can anywise discover. Secondly, the three young gentlemen mentioned in the last section, who had acquired, as far as I know from infancy, as soon as they learned to direct both eyes to an object, saw it single. In these four cases it appears evident that the centres of the retina corresponded originally, and before custom could produce any such effect. For Mr. Cheselden's young gentleman had never been so accustomed to see at all before he was couched, and the other three had never been accustomed to direct the axes of both eyes to the object. Thirdly, from the facts recited in section 13, it appears that from the time we are capable of observing the phenomena of single and double vision, custom makes no change in them. I have amused myself with such observations for more than 30 years, and in every case wherein I saw the object double at first, I see it to this day, notwithstanding the constant experience of its being single. In other cases where I know there are two objects, there appears only one, after thousands of experiments. Let a man look at a familiar object through a polyhedron or multiplying glass every hour of his life. The number of visible appearances will be the same at last as at first, nor does any number of experiments or length of time make the least change. Effects produced by habit must vary according as the acts by which the habit is acquired are more or less frequent. But the phenomena of single and double vision are so invariable and uniform in all men, are so exactly regulated by mathematical rules, that I think we have good reason to conclude that they are not the effect of custom, but of fixed and immutable laws of nature. Section 18 of Dr. Porterfield's account of single and double vision. Bishop Berkeley and Dr. Smith seem to attribute too much to custom in vision, Dr. Porterfield too little. This ingenious writer thinks that by an original law of our nature, antecedent to custom and experience, we perceive visible objects in their true place, not only as to their direction, but likewise as to their distance from the eye, and therefore he accounts for our seeing objects single with two eyes in this manner. Having the faculty of perceiving the object with each eye in its true place, we must perceive it with both eyes in the same place, and consequently must perceive it single. He is aware that this principle, although it accounts for our seeing objects single with two eyes, yet does not at all account for our seeing objects double, and whereas other writers on this subject take it to be a sufficient cause for double vision that we have two eyes, and only find it difficult to assign a cause for single vision, on the contrary, Dr. Porterfield's principle throws all the difficulty on the other side. Therefore, in order to account for the phenomena of double vision, he advances another principle without signifying whether he conceives it to be an original law of our nature or the effect of custom. It is that our natural perception of the distance of objects from the eye is not extended to all the objects that fall within the field of vision, but limited to that which we directly look at, and that the circumjacent objects, whatever be their real distance, are seen at the same distance with the object we look at, as if they were all in the surface of a sphere whereof the eye is the centre. Thus single vision is accounted for by our seeing the true distance of an object which we look at, and double vision by a false appearance of distance in objects which we do not directly look at. We agree with this learned and ingenious author that it is by a natural and original principle that we see visible objects in a certain direction from the eye, and honour him as the author of this discovery. But we cannot assent to either of those principles by which he explains single and double vision, for the following reasons. 1. Our having natural and original perception of the distance of objects from the eye appears contrary to a well-attested fact. For the young gentleman couched by Mr. Cheselden imagined at first that whatever he saw touched his eye, as what he felt touched his hand. 2. The perception we have of the distance of objects from the eye, whether it be from nature or custom, is not so accurate and determinate as is necessary to produce single vision. A mistake of the 20th or 30th part of the distance of a small object, such as a pin, ought, according to Dr. Portersfield's hypothesis, to make it appear double. Very few can judge of the distance of a visible object with such accuracy. Yet we never find double vision produced by mistaking the distance of the object. There are many cases in vision, even with the naked eye, wherein we mistake the distance of an object by 1/2 or more. Why do we see such objects single? When I move my spectacles from my eye towards a small object, 2 or 3 feet distant, the object seems to approach so as to be seen at last at about half its real distance. But it is seen single at that apparent distance, as well as when we see it with the naked eye at its real distance. And when we look at an object with a binocular telescope, properly fitted to the eyes, we see it single, while it appears 15 or 20 times nearer than it is. There are then few cases wherein the distance of an object from the eye is seen so accurately as is necessary for single vision upon this hypothesis. This seems to be a conclusive argument against the account given of single vision. We find likewise that false judgments or fallacious appearances of the distance of an object do not produce double vision. This seems to be a conclusive argument against the account given of double vision. 3. The perception we have of the linear distance of objects seems to be wholly the effect of experience. This, I think, hath been proved by Bishop Berkeley and by Dr. Smith, and when we come to point out the means of judging of distance by sight, it will appear that they are all furnished by experience. 4. Supposing that by a law of our nature the distance of objects from the eye were perceived most accurately, as well as their direction, it will not follow that we must see the object single. Let us consider what means such a law of nature would furnish for resolving the question, whether the objects of the two eyes are in one and the same place, and consequently are not two but one. Suppose then 2 right lines, one drawn from the centre of one eye to its object, the other drawn in like manner from the centre of the other eye to its object. This law of nature gives us the direction or position of each of these right lines, and the length of each, and this is all that it gives. These are geometrical data, and we may learn from geometry what is determined by their means. Is it then determined by these data whether the 2 right lines terminate in one and the same point or not? No, truly. In order to determine this, we must have 3 other data. We must know whether the 2 right lines are in one plane. We must know what angle they make, and we must know the distance between the centres of the eyes. And when these things are known, we must apply the rules of trigonometry before we can resolve the question, whether the objects of the 2 eyes are in one and the same place, and consequently whether they are 2 or 1. 5. The false appearance of distance into which double vision is resolved cannot be the effect of custom, for constant experience contradicts it. Neither hath it the features of a law of nature, because it does not answer any good purpose, nor indeed any purpose at all, but deceive us. But why should we seek for arguments in a question concerning what appears to us or does not appear? The question is, at what distance do the objects now in my eye appear? Do they all appear at one distance, as if placed in the concave surface of a sphere, the eye being in the centre? Every man surely may know this with certainty, and if he will but give attention to the testimony of his eyes, needs not ask a philosopher how visible objects appear to him. Now, it is very true that if I look up to a star in the heavens, the other stars that appear at the same time do appear in this manner. Yet this phenomenon does not favour Dr. Porterfield's hypothesis, for the stars and heavenly bodies do not appear at their true distances when we look directly to them, any more than when they are seen obliquely. And if this phenomenon be an argument for Dr. Porterfield's second principle, it must destroy the first. The true cause of this phenomenon will be given afterwards. Therefore, setting it aside for the present, let us put another case. I sit in my room and direct my eyes to the door, which appears to be about 16 feet distant. At the same time I see many other objects faintly and obliquely, the floor cloth, the table which I write upon, papers, standish, candle, and etc. Now, do all these objects appear at the same distance of 16 feet upon the closest attention? I find they do not. End of Chapter 6, Part 4. Recording by Stephen Reynolds, Durham, Connecticut. Chapter 6, Part 5 of An Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Stephen Reynolds. An Inquiry into the Human Mind on the Principles of Common Sense by Thomas Reid. Chapter 6, Part 5. Section 19. Of Dr. Briggs' theory and Sir Isaac Newton's conjecture on this subject. I am afraid the reader, as well as the writer, is already tired of the subject of single and double vision. The multitude of theories advanced by authors of great name, and the multitude of facts observed without sufficient skills in optics, or related without attention to the most material and decisive circumstances, have equally contributed to perplex it. In order to bring it to some issue, I have in the 13th section given a more full and regular deduction than had been given heretofore of the phenomena of single and double vision, in those whose sight is perfect, and have traced them up to one general principle, which appears to be a law of vision in human eyes that are perfect, and in their natural state. In the 14th section I have made it appear that this law of vision, although excellently adapted to the fabric of the human eye, cannot answer the purposes of vision in some other animals, and therefore very probably is not common to all animals. The purpose of the 15th and 16th sections is to inquire whether there be any deviation from this law of vision in those who squint, a question which is of real importance in the medical art, as well as in the philosophy of vision, but which after all hath been observed and written on this subject, seems not to be ripe for a determination, for want of proper observations. Those who have had skill to make proper observations have wanted opportunities, and those who have had opportunities have wanted skill or attention. I have therefore thought it worth while to give a distinct account of the observations necessary for the determinations of this question, and what conclusions may be drawn from the facts observed. I have likewise collected and set in one view the most conclusive facts that have occurred in authors, or have fallen under my own observation. It must be confessed that these facts, when applied to the question in hand, make a very poor figure, and the gentlemen of the medical faculty are called upon for the honour of their profession, and for the benefit of mankind, to add to them. All the medical and all the optical writers upon the strabismus that I have met with, except Dr. Jurin, either affirm or take it for granted that squinting persons see the object with both eyes, and yet see it single. Dr. Jurin affirms that squinting persons never see the object with both eyes, and that if they did, they would see it double. If the common opinion be true, the cure of a squint would be as pernicious to the sight of the patient, as the causing of a permanent squint would be to one who naturally has no squint, and therefore no physician ought to attempt such a cure. No patient ought to submit to it. But if Dr. Jurin's opinion be true, most young people that squint may cure themselves by taking some pains, and may not only remove the deformity, but at the same time improve their sight. If the common opinion be true, the centres and other points of the two retinae in squinting persons do not correspond as in other men, and nature in them deviates from her common rule. But if Dr. Juran's opinion be true, there is reason to think that the same general law of vision which we have found in perfect human eyes extends also to those which squint. It is impossible to determine by reasoning which of these opinions is true, or whether one may not be found true in some patients and the other in others. Here experience and observation are our only guides, and a deduction of instances is the only rational argument. It might therefore have been expected that the patrons of the contrary opinions should have given instances in support of them that are clear and indisputable. But I have not found one such instance in either side of the question, in all the authors I have met with. I have given 3 instances from my own observation, in confirmation of Dr. Juran's opinion, which admit of no doubt, and one which leans rather to the other opinion, but is dubious. And here I must leave the matter for further observation. In the 17th section I have endeavoured to shew that the correspondence and sympathy of certain points of the two retinae, into which we have resolved all the phenomena of single and double vision, is not, as Dr. Smith conceived, the effect of custom, nor can be changed by custom, but is a natural and original property of human eyes, and in the last section that it is not owing to an original and natural perception of the true distance of objects from the eye, as Dr. Porterfield imagined. After this recapitulation, which is intended to relieve the attention of the reader, shall we enter into more theories upon this subject? That of Dr. Briggs, first published in England in the Philosophical Transactions, afterwards in Latin under the title of Nova Visionis Theoria, with a prefatory epistle of Sir Isaac Newton to the author, amounts to this, that the fibres of the optic nerves passing from corresponding points of the retinae to the thalami nervorum opticorum, having the same length, the same tension, and a similar situation, will have the same tone, and therefore their vibrations, excited by the impression of the rays of light, will be like unisons in music, and will present one and the same image to the mind. But the fibres passing from parts of the retinae which do not correspond, having different tensions and tones, will have discordant vibrations, and therefore present different images to the mind. I shall not enter upon a particular examination of this theory. It is enough to observe, in general, that it is a system of conjectures concerning things of which we are entirely ignorant, and that all such theories in philosophy deserve rather to be laughed at than to be seriously refuted. From the first dawn of philosophy to this day it hath been believed that the optic nerves are intended to carry the images of visible objects from the bottom of the eye to the mind, and that the nerves belonging to the organs of the other senses have a like office. But how do we know this? We conjecture it, and taking this conjecture for a truth, we consider how the nerves may best answer this purpose. The system of the nerves for many ages was taken to be a hydraulic engine, consisting of a bundle of pipes which carried to and fro a liquor called animal spirits. About the time of Dr. Briggs, it was thought rather to be a stringed instrument, composed of vibrating cords, each of which had its proper tension and tone. But some, with as great probability, conceived it to be a wind instrument, which played its part by the vibrations of an elastic ether in the nervous fibrils. These, I think, are all the engines into which the nervous system hath been moulded by philosophers, for conveying the images of sensible things from the organ to the sensorium, and for all that we know of the matter, every man may freely choose which he thinks fittest for the purpose. For from fact and experiment no one of them can claim preference to another. Indeed, they all seem so unhandy engines for carrying images, that a man would be tempted to invent a new one. Since, therefore, a blind man may guess as well in the dark as one that sees, I beg leave to offer another conjecture touching the nervous system, which I hope will answer the purpose as well as those we have mentioned, and which recommends itself by its simplicity. Why may not the optic nerves, for instance, be made up of empty tubes, opening their mouths wide enough to receive the rays of light, which form the image upon the retina, and gently conveying them safe and in their proper order to the very seat of the soul, until they flash in her face? It is easy for an ingenious philosopher to fit the calibre of these empty tubes to the diameter of the particles of light, so as they shall receive no grosser kind of matter. And if these rays should be in danger of mistaking their way, an expedient may also be found to prevent this, for it requires no more than to bestow upon the tubes of the nervous system a peristaltic motion like that of the alimentary tube. It is a peculiar advantage of this hypothesis that although all philosophers believe that the species or images of things are conveyed by the nerves to the soul, yet none of their hypotheses shew how this may be done. For how can the images of sound, taste, smell, colour, figure, and all sensible qualities be made out of the vibrations of musical chords, or the undulations of animal spirits or of ether? We ought not to suppose means inadequate to the end. Is it not as philosophical and more intelligible to conceive that as the stomach receives its food, so the soul receives her images by a kind of nervous digulation? I might add that we need only continue this peristaltic motion of the nervous tubes from the sensorium to the extremities of the nerves that serve the muscles, in order to account for the muscular motion. Thus nature will be consonant to herself, and as sensation will be the conveyance of the ideal aliment to the mind, so muscular motion will be the expulsion of the recommentitious part of it. For who can deny that the images of things conveyed by sensation may, after due concoction, become fit to be thrown off by muscular motion? I only give hints of these things to the ingenious, hoping that in time this hypothesis may be wrought up into a system as truly philosophical as that of animal spirits or the vibration of nervous fibres. To be serious, in the operations of nature, I hold the theories of a philosopher, which are unsupported by fact, in the same estimation with the dreams of a man asleep, or the ravings of a madman. We laugh at the Indian philosopher, who, to account for the support of the earth, contrived the hypothesis of a huge elephant, and to support the elephant, a huge tortoise. If we will candidly confess the truth, we know as little of the operation of the nerves as he did of the manner in which the earth is supported, and our hypotheses about animal spirits, or about the tension and vibration of the nerves, are as like to be true as his about the support of the earth. His elephant was a hypothesis, and our hypotheses are elephants. Every theory in philosophy which is built on pure conjecture is an elephant, and every theory that is supported partly by fact and partly by conjecture is like Nebuchadnezzar's image, whose feet were partly of iron and partly of clay. The great Newton first gave an example to philosophers which always ought to be, but rarely hath been, followed, by distinguishing his conjectures from his conclusions, and putting the former by themselves in the modest form of queries. This is fair and legal, but all other philosophical traffic and conjecture ought to be held contraband and illicit. Indeed, his conjectures have commonly more foundation in fact, and more verisimilitude than the dogmatic theories of most other philosophers. And therefore we ought not to omit that which he hath offered concerning the cause of our seeing objects single with two eyes, in the 15th century annexed to his Optics. Are not the species of objects seen with both eyes united where the optic nerves meet, before they come into the brain, the fibres on the right side of both nerves uniting there, and after union going thence into the brain, in the nerve which is on the right side of the head, and the fibres on the left side of both nerves uniting in the same place, and after union going into the brain, in the nerve which is on the left side of the head, and these two nerves meeting in the brain in such a manner that their fibres make but one entire species or picture, half of which on the right side of the sensorium comes from the right side of both eyes, through the right side of both optic nerves, to the place where the nerves meet, and from thence on the right side of the head into the brain, and the other half on the left side of the sensorium comes in like manner from the left side of both eyes. For the optic nerves of such animals as look the same way with both eyes, as men, dogs, sheep, oxen, and etc., meet before they come into the brain, but the optic nerves of such animals as do not look the same way with both eyes, as of fishes and the chameleon, do not meet, and if I am rightly informed. I beg leave to distinguish this query into two, which are of very different natures, one being purely anatomical, the other relating to the carrying species or pictures of visible objects to the sensorium. The first question is, whether the fibres coming from the corresponding points of the two retinae do not unite at the place where the optic nerves meet, and continue united from thence to the brain, so that the right optic nerve, after the meeting of the two nerves, is composed of the fibres coming from the right side of both retinae, and the left of the fibres coming from the left side of both retinae. This is undoubtedly a curious and rational question, because if we could find ground from anatomy to answer it in the affirmative, it would lead us a step forward in discovering the cause of the correspondence and sympathy which there is between certain points of the two retinae. For although we know not what is the particular function of the optic nerves, yet it is probable that some impression made upon them, and communicated along their fibres, is necessary to vision. And whatever be the nature of this impression, if two fibres are united into one, an impression made upon one of them, or upon both, may probably produce the same effect. Anatomists think it a sufficient account of a sympathy between two parts of the body when they are served by branches of the same nerve. We should therefore look upon it as an important discovery in anatomy, if it were found that the same nerve sent branches to the corresponding points of the retinae. But hath any such discovery been made? No, not so much as in one subject, as far as I can learn. But in several subjects the contrary seems to have been discovered. Dr. Porterfield hath given us two cases at length from Vesalius, and one from Cassiopinus, wherein the optic nerves, after touching one another as usual, appeared to be reflected back to the same side whence they came, without any mixture of their fibres. Each of these persons had lost an eye some time before his death, and the optic nerve belonging to that eye was shrunk, so that it could be distinguished from the other at the place where they met. Another case, which the same author gives, from Vesalius, is still more remarkable, for in it the optic nerves do not touch at all, and yet, upon inquiry, those who were most familiar with the person in his lifetime declared that he never complained of any defect of sight, or of his seeing objects double. Daemerbroek tells us that Aquapendens and Valverde likewise affirm that they have met with subjects wherein the optic nerves did not touch. As these observations were made before Sir Isaac Newton put this query, it is uncertain whether he was ignorant of them, or whether he suspected some inaccuracy in them, and desired that the matter might be more carefully examined. But from the following passage of the most accurate Winslow, it does not appear that later observations have been more favourable to his conjecture. The union of these optic nerves by the small curvatures of their conua is very difficult to be unfolded in human bodies. This union is commonly found to be very close, but in some subjects it seems to be no more than a strong adhesion. in others to be partly made by an intersection of crossing of fibres. They have been found quite separate, and in other subjects one of them has been found to be very much altered, both in size and colour, through its whole passage, the other remaining in its natural state. When we consider this conjecture of Sir Isaac Newton by itself, it appears more ingenious and to have more verisimilitude than anything that has been offered upon the subject. And we admire the caution and modesty of the author in proposing it only as a subject of inquiry. But when we compare it with the observations of anatomists which contradict it, we are naturally led to this reflection, that if we trust to the conjectures of men of the greatest genius in the operation of nature, we have only the chance of going wrong in an ingenious manner. The second part of the query is, whether the two species of objects from the two eyes are not, at the place where the optic nerves meet, united into one species or picture, half of which is carried thence to the sensorium in the right optic nerve, and the other half in the left. Whether these two halves are not so put together again at the sensorium as to make one species or picture. Here it seems natural to put the previous question, what reason have we to believe that pictures of objects are at all carried to the sensorium, either by the optic nerves or by any other nerves? Is it not possible that this great philosopher, as well as many of a lower form, having been led into this opinion at first by education, may have continued in it because he never thought of calling it in question? I confess this was my own case for a considerable part of my life, but since I was led by accident to think seriously what reason I had to believe it, I could find none at all. It seems to be a mere hypothesis, as much as the Indian philosopher's elephant. I am not conscious of any pictures of external objects in my sensorium, any more than in my stomach. The things which I perceive by my senses appear to be external, and not in any part of the brain, and my sensations, properly so called, have no resemblances of external objects. The conclusion from all that hath been said, in no less than 7 sections upon our seeing objects single with 2 eyes, is this, that by an original property of human eyes, objects painted upon the centres of the 2 retinae, or upon points similarly situate with regard to the centres, appear in the same visible place; that the most plausible attempts to account for this property of the eye have been unsuccessful, and therefore that it must be either a primary law of our constitution, or the consequence of some more general law which is not yet discovered. We have now finished what we intended to say, both of the visible appearances of things to the eye, and of the laws of our constitution by which those appearances are exhibited. But it was observed in the beginning of this chapter that the visible appearances of objects serve only as signs of their distance, magnitude, figure, and other tangible qualities. The visible appearance is that which is presented to the mind by nature according to those laws of our constitution which have been explained. But the thing signified by that appearance is that which is presented to the mind by custom. When one speaks to us in a language that is familiar, we hear certain sounds, and this is all the effect that his discourse has upon us by nature. But by custom we understand the meaning of these sounds, and therefore we fix our attention not upon the sounds, but upon the things signified by them. In like manner, we see only the visible appearance of objects by nature, but we learn by custom to interpret these appearances and to understand their meaning. And when this visual language is learned and becomes familiar, we attend only to the things signified, and cannot without great difficulty attend to the signs by which they are presented. The mind passes from one to the other so rapidly and so familiarly that no trace of the sign is left in the memory, and we seem immediately, and without the intervention of any sign, to perceive the thing signified. When I look at the apple tree which stands before my window, I perceive at the first glance its distance and magnitude, the roughness of its trunk, the disposition of its branches, the figure of its leaves and fruit. I seem to perceive all these things immediately. The visible appearance which presented them all to the mind has entirely escaped me. I cannot, without great difficulty and painful abstraction, attend to it, even when it stands before me. Yet it is certain that this visible appearance only is presented to my eye by nature, and that I learned by custom to collect all the rest from it. If I had never seen before now, I should not perceive either the distance or tangible figure of the tree, and it would have required the practice of seeing for many months to change that original perception which nature gave me by my eyes, into that which I now have by custom. The objects which we see naturally and originally, as hath been before observed, have length and breadth, but no thickness nor distance from the eye. Custom, by a kind of legerdemain, withdraws gradually from these original and proper objects of sight, and substitutes in their place objects of touch, which have length, breadth, and thickness, and a determinate distance from the eye. By what means this change is brought about, and what principles of the human mind concur in it, we are next to inquire. Section 20. Of Perception in general. Sensation and the perception of external objects by the senses, though very different in their nature, have commonly been considered as one and the same thing. The purposes of common life do not make it necessary to distinguish them, and the received opinions of philosophers tend rather to confound them. But without attending carefully to this distinction, it is impossible to have any just conception of the operations of our senses. The most simple operations of the mind admit not of a logical definition. All we can do is to describe them, so as to lead those who are conscious of them in themselves to attend to them and reflect upon them, and it is often very difficult to describe them so as to answer this intention. The same mode of expression is used to denote sensation and perception, and therefore we are apt to look upon them as things of the same nature. Thus I feel a pain, I see a tree. The first denoteth a sensation, the last a perception. The grammatical analysis of both expressions is the same, for both consist of an active verb and an object. But if we attend to the things signified by these expressions, we shall find that in the first the distinction between the act and the object is not real, but grammatical. In the second, the distinction is not only grammatical, but real. The form of the expression, I feel pain, might seem to imply that the feeling is something distinct from the pain felt. Yet in reality there is no distinction. As thinking a thought is an expression which would signify no more than thinking, so feeling a pain signifies no more than being pained. What we have said of pain is applicable to every other mere sensation. It is difficult to give instances, very few of our sensations having names, and where they have, the same being common to the sensation and to something else which is associated with it. But when we attend to the sensation by itself, and separate it from other things which are conjoined with it, in the imagination, it appears to be something which can have no existence, but in a sentient mind, no distinction from the act of the mind by which it is felt. Perception, as we here understand it, hath always an object distinct from the act by which it is perceived, an object which may exist whether it be perceived or not. I perceive a tree that grows before my window. There is here an object which is perceived, and an act of the mind by which it is perceived. And these two are not only distinguishable, but they are extremely unlike in their natures. The object is made up of a trunk, branches, and leaves, but the act of the mind by which it is perceived hath neither trunk, branches, nor leaves. I am conscious of this act of my mind, and I can reflect upon it, but it is too simple to admit of an analysis. and I cannot find proper words to describe it. I find nothing that resembles it so much as the remembrance of the tree, or the imagination of it. Yet both these differ essentially from the perception. They differ likewise one from another. It is in vain that a philosopher assures me that the imagination of the tree, the remembrance of it, and the perception of it are all one and differ only in degree of vivacity. I know the contrary, for I am as well acquainted with all the three as I am with the apartments of my own house. I know this also, that the perception of an object implies both a conception of its form and a belief of its present existence. I know, moreover, that this belief is not the effect of argumentation and reasoning. It is the immediate effect of my constitution. I am aware that this belief which I have in perception stands exposed to the strongest batteries of skepticism, but they make no great impression upon it. The skeptic asks me, why do you believe the existence of the external object which you perceive? This belief, sir, is none of my manufacture. It came from the mint of nature. It bears her image and subscription, and if it is not right, the fault is not mine. I even took it upon trust and without suspicion. Reason, says the skeptic, is the only judge of truth, and you ought to throw off every opinion and every belief that is not grounded on reason. Why, sir, should I believe the faculty of reason more than that of perception? They came both out of the same shop, and were made by the same artist. And if he puts one piece of false ware into my hands, what should it hinder him from putting another? Perhaps the skeptic will agree to distrust reason, rather than give any credit to perception. For, says he, since by your own concession, the object which you perceive, and the act of your mind, by which you perceive it, are quite different things. The one may exist without the other, and as the object may exist without being perceived, so the perception may exist without an object. There is nothing shameful in a philosopher as to be deceived and deluded, and therefore you ought to resolve firmly to withhold assent, and to throw off this belief of external objects which may be all delusion. For my part, I will never attempt to throw it off, and although the sober part of mankind will not be very anxious to know my reasons, yet if they can be of use to any skeptic, they are these. First, because it is not in my power, why then should I make a vain attempt? It would be agreeable to fly to the moon, and to make a visit to Jupiter and Saturn, but when I know that nature has bound me down by the law of gravitation to this planet which I inhabit, I rest contented, and quietly suffer myself to be carried along in its orbit. My belief is carried along by perception as irresistibly as my body by the earth, and the greatest skeptic will find himself to be in the same condition. He may struggle hard to disbelieve the information of his senses, as a man does to swim against a torrent, but it is in vain. It is in vain that he strains every nerve and wrestles with nature, and with every object that strikes upon his senses. For after all, when his strength is spent in the fruitless attempt, he will be carried down the torrent with the common herd of believers. Secondly, I think it would not be prudent to throw off this belief if it were in my power. If nature intended to deceive me, and impose upon me by false appearances, and I by my great cunning and profound logic have discovered the imposture, prudence would dictate to me in this case even to put up this indignity done me as quietly as I could, and not to call her an impostor to her face, lest she should be even with me in another way. For what do I gain by resenting this injury? You ought at least not to believe what she says. This indeed seems reasonable, if she intends to impose upon me. But what is the consequence? I resolve not to believe my senses. I break my nose against a post that comes in my way. I step into a dirty kennel, and after 20 such wise and rational actions, I am taken up and clapped into an outhouse. Now I confess I would rather make one of the credulous fools, whom nature imposes upon, than of those wise and rational philosophers who resolve to withhold assent at all this experience. If a man pretends to be a skeptic with regard to the informations of sense, and yet prudently keeps out of harm's way as other men do, he must excuse my suspicion that he either acts the hypocrite, or imposes upon himself. For if the scale of his belief were so evenly poised as to lean no more to one side than to the contrary, it is impossible that his actions could be directed by any rules of common prudence. Thirdly, although the two reasons already mentioned are perhaps two more than enough, I shall offer a third. I give implicit belief to the informations of nature by my senses for a considerable part of my life, before I had learned so much logic as to be able to start a doubt concerning them. And now, when I reflect upon what is past, I do not find that I have been imposed upon by this belief. I find that without it I must have perished by 1,000 accidents. I find that without it I should have been no wiser now than when I was born. I should not even have been able to acquire that logic which suggests these sceptical doubts with regard to my senses. Therefore I consider this instructive belief as one of the best gifts of nature. I thank the author of my being who bestowed it upon me, before the eyes of my reason were opened, and still bestows it upon me to be my guide, where reason leaves me in the dark. And now I yield to the direction of my senses, not from instinct only, but from confidence and trust in a faithful and beneficent monitor, grounded upon the experience of his paternal care and goodness. In all this I deal with the author of my being no otherwise than I thought it reasonable to deal with my parents and tutors. I believed by instinct whatever they told me, long before I had the idea of a lie, or thought of the possibility of their deceiving me. Afterwards, upon reflection, I found they had acted like fair and honest people, who wished me well. I found that if I had not believed what they told me, before I could give a reason of my belief, I had to this day been little better than a changeling. And although this natural credulity hath sometimes occasioned my being imposed upon by deceivers, yet it hath been of infinite advantage to me upon the whole. Therefore I consider it as another good gift of nature, and I continue to give that credit from reflection to those of whose integrity and veracity I have had experience, which before I gave from instinct. There is a much greater similitude than is commonly imagined between the testimony of nature given by our senses, and the testimony of men given by language. The credit we give to both is at first the effect of an instinct only. When we grow up and begin to reason about them, the credit given to human testimony is restrained and weakened by the experience we have of deceit. But the credit given to the testimony of our senses is established and confirmed by the uniformity and constancy of the laws of nature. Our perceptions are of two kinds. Some are natural and original, others acquired and the fruit of experience. When I perceive that this is the taste of cider, that of brandy, that this is the smell of an apple, that of an orange, that this is the noise of thunder, that the ringing of bells, this the sound of a coach passing, that the voice of such a friend, these perceptions and others of the same kind are not original, they are acquired. But the perception which I have by touch of the hardness and softness of bodies, of their extension, figure, and motion, is not acquired, it is original. In all our senses, the acquired perceptions are many more than the original, especially in sight. By this sense we perceive originally the visible figure and colour of bodies only, and their visible place. But we learn to perceive by the eye almost everything which we can perceive by touch. The original perceptions of this sense serve only as signs to introduce the acquired. The signs by which objects are presented to us in perception are the language of nature to man, and as in many respects it hath great affinity with the language of man to man, so particularly in this, that both are partly natural and original, partly acquired by custom. Our original or natural perceptions are analogous to the natural language of man to man, of which we took notice in the 4th chapter, and our acquired perceptions are analogous to artificial language, which in our mother tongue is got very much in the same manner with our acquired perceptions, as we shall afterwards more fully explain. Not only men, but children, idiots, and brutes acquire by habit many perceptions which they had not originally. Almost every employment in life hath perceptions of this kind that are peculiar to it. The shepherd knows every sheep of his flock, as we do our acquaintance, and can pick them out of another flock one by one. The butcher knows by sight the weight and quality of his beeves and sheep before they are killed. The farmer perceives by his eye very nearly the quantity of hay in a rick, or of corn in a heap. The sailor sees the burden, the built, and the distance of a ship at sea, while she is a great way off. Every man accustomed to writing distinguishes his acquaintance by their handwriting, as he does by their faces, and the painter distinguishes in the works of his art the style of all the great masters. In a word, acquired perception is very different in different persons, according to the diversity of objects about which they are employed, and the application they bestow in observing them. Perception ought not only to be distinguished from sensation, but likewise from that knowledge of objects of sense which is got by reasoning. There is no reasoning in perception, as hath been observed. The belief which is implied in it is the effect of instinct. But there are many things with regard to sensible objects which we can infer from what we perceive, and such conclusions of reason ought to be distinguished from what is merely perceived. When I look at the moon, I perceive her to be sometimes circular, sometimes horned, and sometimes gibbous. This is simple perception, and is the same in the philosopher and in the clown. But from these various appearances of her enlightened part, I infer that she is really of a spherical figure. This conclusion is not obtained by simple perception, but by reasoning. Simple perception has the same relation to the conclusions of reason drawn from our perceptions, as the axioms in mathematics have to the propositions. I cannot demonstrate that two quantities which are equal to the same quantity are equal to each other. Neither can I demonstrate that the tree which I perceive exists. But by the constitution of my nature, my belief is irresistibly carried along by my apprehension of the axiom, and by the constitution of my nature, my belief is no less irresistibly carried along by my perception of the tree. All reasoning is from principles. The first principles of mathematical reasoning are mathematical axioms and definitions, and the first principles of all our reasoning about existences are our perceptions. The first principles of every kind of reasoning are given us by nature, and are of equal authority with the faculty of reason itself, which is also the gift of nature. The conclusions of reason are all built upon first principles, and can have no other foundation. Most justly, therefore, do such principles disdain to be tried by reason, and laugh at all the artillery of the logician when it is directed against them. When a long train of reasoning is necessary in demonstrating a mathematical proposition, it is easily distinguished from an axiom, and they seem to be things of a very different nature. But there are some propositions which lie so near to axioms that it is difficult to say whether they ought to be held as axioms or demonstrated as propositions. The same thing holds with regard to perception, and the conclusions drawn from it. Some of these conclusions follow our perceptions so easily, and are so immediately connected with them, that it is difficult to fix the limit which divides the one from the other. Perception, whether original or acquired, implies no exercise of reason, and is common to men, children, idiots, and brutes. The more obvious conclusions drawn from our perceptions by reason make what we call common understanding, by which men conduct themselves in the common affairs of life, and by which they are distinguished from idiots. The more remote conclusions, which are drawn from our perceptions by reason, make what we commonly call science, in the various parts of nature, whether in agriculture, medicine, mechanics, or in any part of natural philosophy. When I see a garden in good order, containing a great variety of things of the best kinds, and in the most flourishing condition, I immediately conclude from these signs the skill and industry of the gardener. A farmer, when he rises in the morning, and perceives that the neighbouring brook overflows his field, concludes that a great deal of rain hath fallen in the night. Perceiving his fence broken and his corn trodden down, he concludes that some of his own or his neighbour's cattle have broke loose. Perceiving that his stable door is broke open, and some of his horses gone, he concludes that a thief has carried them off. He traces the prints of his horse's feet in the soft ground, and by them discovers which road the thief hath taken. There are instances of common understanding which dwells so near to perception that it is difficult to trace the line which divides the one from the other. In like manner, the science of nature dwells so near to common understanding that we cannot discern where the latter ends and the former begins. I perceive that bodies lighter than water swim in water, and that those which are heavier sink. Hence I conclude that if a body remains wherever it is put under water, whether at the top or bottom, it is precisely of the same weight with water. If it will rest only when part of it is above water, it is lighter than water. And the greater the part above water is compared with the whole, the lighter is the body. If it had no gravity at all, it would make no impression upon the water, but stand wholly above it. Thus every man by common understanding has a rule by which he judges of the specific gravity of bodies which swim in water, and a step or two more leads him into the science of hydrostatics. All that we know of nature or of existence may be compared to a tree which have its root, trunk, and branches. In this tree of knowledge, perception is the root, common understanding is the trunk, and the sciences are the branches. End of Chapter 6, Part 5. Recording by Stephen Reynolds, Durham, Connecticut.
Chapter 6, Part 6 of an Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by K. Hand. An Inquiry into the Human Mind on the Principles of Common Sense by Thomas Reid. Chapter 6, Part 6. Section 21. Of the process of nature in perception. Although there is no reasoning in perception, yet there are certain means and instruments which, by the appointment of nature, must intervene between the object and our perception of it, and by these our perceptions are limited and regulated. First, if the object is not in contact with the organ of sense, there must be some medium which passes between them. Thus in vision the rays of light, in hearing the vibrations of elastic air, in smelling, the effluvia of the body smelled, must pass from the object to the organ, otherwise we have no perception. Secondly, there must be some action or impression upon the organ of sense, either by the immediate application of the object, or by the medium that goes between them. Thirdly, the nerves which go from the brain to the organ must receive some impression by means of that which was made upon the organ, and probably by means of the nerves some impression must be made upon the brain. Fourthly, the impression made upon the organ, nerves, and brain is followed by a sensation. And last of all, this sensation is followed by the perception of the object. Thus our perception of objects is the result of a train of operations, some of which affect the body only, others affect the mind. We know very little of the nature of some of these operations. We know not at all how they are connected together, or in what way they contribute to the perception which is the result of the whole. But, by the laws of our constitution, we perceive objects in this, and in no other way. There may be other beings who can perceive external objects without rays of light, or vibrations of air, or effluvia of bodies, without impressions on bodily organs, or even without sensations. But we are so framed by the Author of Nature that even when we are surrounded by external objects we may perceive none of them. Our faculty of perceiving an object lies dormant until it is roused and stimulated by a certain corresponding sensation. Nor is this sensation always at hand to perform its office, for it enters into the mind only in consequence of a certain corresponding impression made on the organ of sense by the object. Let us trace this correspondence of impressions, sensations, and perceptions as far as we can, beginning with that which is first in order, the impression made upon the bodily organ. But alas! we know not of what nature these impressions are, far less how they excite sensations in the mind. We know that one body may act upon another by pressure, by percussion, by attraction, by repulsion, and probably in many other ways which we neither know nor have names to express. But in which of these ways objects, when perceived by us, act upon the organs of sense, these organs upon the nerves, and the nerves upon the brain, we know not. Can any man tell me how, in vision, the rays of light act upon the retina, how the retina acts upon the optic nerve, and how the optic nerve acts upon the brain? No man can. When I feel the pain of the gout in my toe, I know that there is some unusual impression made upon that part of my body. But of what kind is it? Are the small vessels distended with some redundant elastic or unelastic fluid? Are the fibers unusually stretched? Are they torn asunder by force, or gnawed and corroded by some acrid humor? I can answer none of these questions. All that I feel is pain, which is not an impression upon the body but upon the mind, and all that I perceive by this sensation is, that some distemper in my toe occasions this pain. But as I know not the natural temper and texture of my toe when it is at ease, I know as little what change or disorder of its parts occasions this uneasy sensation. In like manner, in every other sensation there is without a doubt some impression made upon the organ of sense, but an impression of which we know not the nature. It is too subtle to be discovered by our senses, and we may make 1,000 conjectures without coming near the truth. If we understood the structure of our organs of sense so minutely as to discover what effects are produced upon them by external objects, this knowledge would contribute nothing to our perception of the object, for they perceive as distinctly who know least about the manner of perception, as the greatest adepts. It is necessary that the impression be made upon our organs, but not that it be known. Nature carries on this part of the process of perception without our consciousness or concurrence. But we cannot be unconscious of the next step in this process, the sensation of the mind, which always immediately follows the impression made upon the body. It is essential to a sensation to be felt, and it can be nothing more than we feel it to be. If we can only acquire the habit of attending to our sensations, we may know them perfectly. But how are the sensations of the mind produced by impressions upon the body? Of this we are absolutely ignorant, having no means of knowing how the body acts upon the mind or the mind upon the body. When we consider the nature and attributes of both, they seem to be so different and so unlike that we can find no handle by which the one may lay hold of the other. There is a deep and dark gulf between them which our understanding cannot pass, and the manner of their correspondence and intercourse is absolutely unknown. Experience teaches us that certain impressions upon the body are constantly followed by certain sensations of the mind, and that, on the other hand, certain determinations of the mind are constantly followed by certain motions in the body, but we see not the chain that ties these things together. Who knows but their connection may be arbitrary and owing to the will of our Maker? Perhaps the same sensations might have been connected with other impressions or other bodily organs. Perhaps we might have been so made as to taste with our fingers, to smell with our ears, and to hear by the nose. Perhaps we might have been so made as to have all the sensations and perceptions which we have, without any impression made upon our bodily organs at all. However these things may be, if nature had given us nothing more than impressions made upon the body, and sensations in our minds corresponding to them, we should in that case have been merely sentient, but not perceptient beings. We should never have been able to form a conception of any external object, far less a belief of its existence. Our sensations have no resemblance to external objects, nor can we discover by our reason any necessary connection between the existence of the former and that of the latter. We might perhaps have been made of such a constitution as to have our present perceptions connected with other sensations. We might perhaps have had the perception of external objects without either impressions upon the organs of sense or sensations. Or lastly, the perceptions we have might have been immediately connected with the impressions upon our organs without any intervention of sensations. This last seems really to be the case in one instance, to wit, in our perception of the visible figure of bodies, as was observed in the 8th section of this chapter. The process of nature in perception by the senses may therefore be conceived as a kind of drama, wherein some things are performed behind the scenes, others are represented to the mind in different scenes, one succeeding another. The impression made by the object upon the organ, either by immediate contact, or by some intervening medium, as well as the impression made upon the nerves and the brain, is performed behind the scenes, and the mind sees nothing of it. But every such impression, by the laws of the drama, is followed by a sensation, which is the first scene exhibited to the mind. And this scene is quickly succeeded by another, which is the perception of the object. In this drama, nature is the actor, we are the spectators. We know nothing of the machinery by means of which every different impression upon the organ, nerves, and brain exhibits its corresponding sensation, or of the machinery by means of which each sensation exhibits its corresponding perception. We are inspired with the sensation, and we are inspired with the corresponding perception, by means unknown. And because the mind passes immediately from the sensation to that conception and belief of the object which we have in perception, in the same manner as it passes from signs to the things signified by them, we have therefore called our sensations signs of external objects, finding no word more proper to express the function which nature hath assigned them in perception, and the relation which they bear to their corresponding objects. There is no necessity of a resemblance between the sign and the thing signified, and indeed no sensation can resemble any external object. But there are two things necessary to our knowing things by means of signs. First, that a real connection between the sign and the thing signified be established, either by the course of nature or by the will and appointment of men. When they are connected by the course of nature, it is a natural sign; when by human appointment, it is an artificial sign. Thus, smoke is a natural sign of fire. Certain features are natural signs of anger, but our words, whether expressed by articulate sounds or by writing, are artificial signs of our thoughts and purposes. Another requisite to our knowing things by signs is that the appearance of the sign to the mind be followed by the conception and belief of the thing signified. Without this, the sign is not understood or interpreted, and therefore is no sign to us, however fit in its own nature for that purpose. Now, there are three ways in which the mind passes from the appearance of a natural sign to the conception and belief of the thing signified: by original principles of our constitution, by custom, and by reasoning. Our original perceptions are got in the first of these ways, our acquired perceptions in the second, and all that reason discovers of the course of nature in the third. In the first of these ways, nature, by means of the sensations of touch, informs us of the hardness and softness of bodies, of their extension, figure, and motion, and of that space in which they move and are placed, as hath been already explained in the 5th chapter of this inquiry. And in the second of these ways, she informs us, by means of our eyes, of almost all the same things which originally we could perceive only by touch. In order therefore to understand more particularly how we learn to perceive so many things by the eye, which originally could be perceived only by touch, it will be proper first to point out the signs by which those things are exhibited to the eye, and their connection with the things signified by them; and secondly, to consider how the experience of this connection produces that habit by which the mind, without any reasoning or reflection, passes from the sign to the conception and belief of the thing signified. Of all the acquired perceptions which we have by sight, the most remarkable is the perception of the distance of objects from the eye. We shall therefore particularly consider the signs by which this perception is exhibited, and only make some general remarks with regard to the signs which are used in other acquired perceptions. § 22. Of the signs by which we learn to perceive distance from the eye. It was before observed in general that the original perceptions of sight are signs which serve to introduce those that are acquired, but this is not to be understood as if no other signs were employed for that purpose. There are several motions of the eyes, which, in order to distinct vision, must be varied, according as the object is more or less distant, and such motions being by habit connected with the corresponding distances of the object, become signs of those distances. These motions were at first voluntary and unconfined, but as the intention of nature was, to produce perfect and distinct vision by their means, we soon learn by experience to regulate them according to that intention only, without the least reflection. A ship requires a different trim for every variation of the direction and strength of the wind. And if we may be allowed to borrow that word, the eyes require a different trim for every degree of light, and for every variation of the distance of the object while it is within certain limits. The eyes are trimmed for a particular object, by contracting certain muscles and relaxing others, as the ship is trimmed for a particular wind by drawing certain ropes and slackening others. The sailor learns the trim of his ship, as we learn the trim of our eyes, by experience. A ship, although the noblest machine that human art can boast, is far inferior to the eye in this respect, that it requires art and ingenuity to navigate her, and a sailor must know what ropes he must pull and what he must slacken to fit her to a particular wind. But with such superior wisdom is the fabric of the eye, and the principles of its motion contrived, that it requires no art nor ingenuity to see by it. Even that part of vision which is got by experience is attained by idiots. We need not know what muscles we are to contract, and what we are to relax, in order to fit the eye to a particular distance of the object. But although we are not conscious of the motions we perform, in order to fit the eyes to the distance of the object, we are conscious of the effort employed in producing these motions, and probably have some sensation which accompanies them, to which we give as little attention as to other sensations. And thus an effort consciously exerted, or a sensation consequent upon that effort, comes to be conjoined with the distance of the object which gave occasion to it, and by this conjunction becomes a sign of that distance. Some instances of this will appear in considering the means or signs by which we learn to see the distance of objects from the eye. In the enumeration of these we agree with Dr. Porterfield, notwithstanding that distance from the eye, in his opinion, is perceived originally, but in our opinion, by experience only. In general, when a near object affects the eye in one manner, and the same object, placed at a greater distance, affects it in a different manner, these various affectations of the eye become signs of the corresponding distances. The means of perceiving distance by the eye will therefore be explained by shewing in what various ways objects affect the eye differently, according to their proximity or distance. 1. It is well known that to see objects distinctly at various distances the form of the eye must undergo some change. And nature hath given us the power of adapting it to near objects, by the contraction of certain muscles, and to distant objects, by the contraction of other muscles. As to the manner in which this is done, and the muscular parts employed, anatomists do not altogether agree. The ingenious Dr. Jurin, in his excellent essay on distinct and indistinct vision, seems to have given the most probable account of this matter, and to him I refer the reader. But whatever be the manner in which this change of the form of the eye is effected, it is certain that young people have commonly the power of adapting their eyes to all distances of the object, from 6 to 7 inches, to 15 or 16 feet, so as to have perfect and distinct vision at any distance within these limits. From this it follows that the effect we consciously employ to adapt the eye to any particular distance of objects within these limits will be connected and associated with that distance, and will become a sign of it. When the object is removed beyond the farthest limit of distinct vision, it will be seen indistinctly, but more or less so, according as its distance is greater or less, so that the degrees of indistinctness of the object may become the signs of distances considerably beyond the farthest limit of distinct vision. If we had no other means but this, of perceiving distance of visible objects, the most distant would not appear to be above 20 or 30 feet from the eye, and the tops of houses and trees would seem to touch the clouds. For in that case, the signs of all greater distances being the same, they have the same signification, and give the same perception of distance. But it is of more importance to observe, that because the nearest limit of distinct vision in the time of youth, when we learn to perceive distance by the eye, is about 6 or 7 inches, no object seen distinctly ever appears to be nearer than 6 or 7 inches from the eye. We can by art make a small object appear distinct, when it is in reality not above half an inch from the eye, either by using a single microscope, or by looking through a small pinhole in a card. When by either of these means an object is made to appear distinct, however small its distance is in reality, it seems to be removed at least to the distance of 6 or 7 inches, that is, within the limits of distinct vision. This observation is the more important because it affords the only reason we can give why an object is magnified either by a single microscope or by being seen through a pinhole, and the only mean by which we can ascertain the degree in which the object will be magnified by either. Thus, if the object is really half an inch distant from the eye and appears to be 7 inches distant, its diameter will seem to be enlarged in the same proportion as its distance, that is, 14 times. 2. In order to direct both eyes to an object, the optic axis must have a greater or less inclination, according as the object is nearer or more distant. And although we are not conscious of this inclination, yet we are conscious of the effort employed in it. By this mean we perceive small distances more accurately than we could do by the conformation of the eye only. And therefore we find that those who have lost the sight of one eye are apt, even within arm's length, to make mistakes in the distance of objects, which are easily avoided by those who see with both eyes. Such mistakes are often discovered in snuffing a candle, in threading a needle, or in filling a teacup. When a picture is seen with both eyes and at no great distance, the representation appears not so natural as when it is seen only with one. The intention of painting being to deceive the eye, and to make things appear at different distances which in reality are upon the same piece of canvas, this deception is not so easily put upon both eyes as upon one, because we perceive the distance of visible objects more exactly and determinately with two eyes than with one. If the shading and relief be executed in the best manner, the picture may have almost the same appearance to one eye as objects themselves would have, but it cannot have the same appearance to both. This is not the fault of the artist, but an unavoidable imperfection in the art. And it is owing to what we have just now observed, that the perception we have of the distance of objects by one eye is more uncertain, and more liable to deception than that which we have by both. The great impediment, and I think the only invincible impediment, to the agreeable deception of the eye which the painter aims at, is a perception which we have of the distance of visible objects from the eye, partly by means of the conformation of the eye, but chiefly by means of the inclination of the optic axes. If this perception could be removed, I see no reason why a picture might not be made so perfect as to deceive the eye in reality, and to be mistaken for the original object. Therefore, in order to judge of the merit of a picture, we ought, as much as possible, to exclude these two means of perceiving the distance of the several parts of it. In order to remove this perception of distance, the connoisseurs in painting use a method which is very proper. They look at the picture with one eye, through a tube which excludes the view of all other objects. By this method, the principal mean whereby we perceive the distance of the object, to wit, the inclination of the optic axes, is entirely excluded. I would humbly propose, as an improvement of this method of viewing pictures, that the aperture of the tube next to the eye should be very small. If it is as small as a pinhole, so much the better, providing there be light enough to see the picture clearly. The reason of this proposal is that, when we look at an object through a small aperture, it will be seen distinctly, whether the conformation of the eye be adapted to its distance or not, and we have no means left to judge of the distance, but the light and coloring, which are in the painter's power. If, therefore, the artist performs his part properly, the picture will by this method affect the eye in the same manner that the object represented would do, which is the perfection of this art. Although the second mean of perceiving the distance of visible objects be more determinate and exact than the first, yet it hath its limits beyond which it can be of no use. For when the optic axes directed to an object are so nearly parallel, that in directing them to an object yet more distant, we are not conscious of any new effort, nor have any different sensation, there our perception of distance stops, and as all more distant objects affect the eye in the same manner, we perceive them to be at the same distance. This is the reason why the sun, moon, planets, and fixed stars, when seen not near the horizon, appear to be all at the same distance, as if they touched the concave surface of a great sphere. The surface of this celestial sphere is at that distance beyond which all objects affect the eye in the same manner. Why this celestial vault appears more distant towards the horizon than towards the zenith will afterwards appear. 3. The colors of objects, according as they are more distant, become more faint and languid, and are tinged more with the azure of the intervening atmosphere. To this we may add, that their minute parts become more indistinct, and their outline less accurately defined. It is by these means chiefly that the painters can represent objects at very different distances upon the same canvas. And the diminution of the magnitude of an object would not have the effect of making it appear to be at a great distance without this degradation of color, and indistinctness of the outline, and of the minute parts. If a painter should make a human figure 10 times less than other human figures that are in the same piece, having the colors as bright and the outline and minute parts as accurately defined, it would not have the appearance of a man at a great distance, but of a pygmy or Lilliputian. When an object hath a known variety of colors, its distance is more clearly indicated by the gradual dilution of the colors into one another, than when it is of one uniform color. In the steeple which stands before me at a small distance, the joinings of the stones are clearly perceptible, the gray color of the stone and the white cement are distinctly limited. When I see it at a greater distance, the joinings of the stones are less distinct, and the colors of the stone and of the cement begin to dilute into one another. At a distance still greater, the joinings disappear altogether, and the variety of color vanishes. In an apple tree which stands at the distance of about 12 feet, covered with flowers, I can perceive the figure and the color of the leaves and petals, pieces of branches, some larger, others smaller, peeping through the interval of the leaves, some of them enlightened by the sun's rays, others shaded, and some openings of the sky are perceived through the whole. When I gradually remove from this tree the appearance, even as to the color, changes every minute. First the smaller parts, then the larger, are gradually confounded and mixed. The colors of the leaves, petals, branches, and sky are gradually diluted into each other, and the color of the whole becomes more and more uniform. This change of appearance, corresponding to the several distances, marks the distance more exactly than if the whole object had been of one color. Dr. Smith, in his Optics, gives us a very curious observation made by Bishop Berkeley in his travels through Italy and Sicily. He observed that in those countries cities and palaces seen at a great distance appeared nearer to him by several miles than they really were, and he very judiciously imputed it to this cause, that the purity of the Italian and Sicilian air gave to very distant objects that degree of brightness and distinctness which, in the grosser air of his own country, was to be seen only in those that are near. The purity of the Italian air has been assigned as the reason why the Italian painters commonly give a more lively color to the sky than the Flemish. Ought they not, for the same reason, to give less degradation of the colors, and less indistinctness of the minute parts in the representation of very distant objects? It is very certain that as, in air uncommonly pure, we are apt to think visible objects nearer, and less than they really are, so, in air uncommonly foggy, we are apt to think them more distant, and larger than the truth. Walking by the seaside in a thick fog, I see an object which seems to me to be a man on horseback, and at the distance of about half a mile. My companion, who has better eyes, or is more accustomed to see such objects in such circumstances, assures me that it is a seagull, and not a man on horseback. Upon a second view I immediately assent to his opinion, and now it appears to me to be a seagull, and at a distance of only 70 or 80 yards. The mistake made on this occasion and the correction of it are both so sudden that we are at a loss whether to call them by the name of judgment, or by that of simple perception. It is not worth while to dispute about names, but it is evident that my belief, both first and last, was produced rather by signs than by arguments, and that the mind proceeded to the conclusion in both cases by habit, and not by ratiocination. And the process of the mind seems to have been this: first, not knowing or not minding the effect of a foggy air on the visible appearance of objects, the object seems to me to have that degradation of color, and that indistinctness of the outline, which objects have at the distance of half a mile. Therefore, from the visible appearance as a sign, I immediately proceed to the belief that the object is half a mile distant. Then this distance, together with the visible magnitude, signify to me the real magnitude, which, supposing the distance to be half a mile, must be equal to that of a man on horseback. And the figure, considering the indistinctness of the outline, agrees with that of a man on horseback. Thus the deception is brought about. But when I am assured that it is a seagull, the real magnitude of a seagull, together with the visible magnitude presented to the eye, immediately suggests the distance, which in this case cannot be above 70 or 80 yards. The indistinctness of the figure likewise suggests the fogginess of the air as its cause, and now the whole chain of signs and things signified seems stronger and better connected than it was before. The half mile vanishes to 80 yards, the man on horseback dwindles to a seagull. I get a new perception, and wonder how I got the former, or what has become of it, for it is now so entirely gone that I cannot recover it. It ought to be observed that in order to produce such deceptions from the clearness or fogginess of the air, it must be uncommonly clear or uncommonly foggy. For we learn from experience to make allowance for that variety of constitutions of the air which we have been accustomed to observe, and of which we are aware. Bishop Berkeley therefore committed a mistake when he attributed the large appearance of the horizontal moon to the faintness of her light, occasioned by its passing through a larger tract of atmosphere. For we are so much accustomed to see the moon in all degrees of faintness and brightness, from the greatest to the least, that we learn to make allowance for it, and do not imagine her magnitude increased by the faintness of her appearance. Besides, it is certain that the horizontal moon, seen through a tube which cuts off the view of the adjacent ground, and of all terrestrial objects, loses all that unusual appearance of magnitude. 4. We frequently perceive the distance of objects, by means of intervening or contiguous objects, whose distance or magnitude is otherwise known. When I perceive certain fields or tracts of ground to lie between me and an object, it is evident that these may become signs of its distance. And although we have no particular information of the dimensions of such fields or tracts, yet their similitude to others which we know suggests their dimensions. We are so much accustomed to measure with our eye the ground which we travel, and to compare the judgments of distances formed by sight with our experience or information, that we learn by degrees in this way to form a more accurate judgment of the distance of terrestrial objects than we could do by any of the means before mentioned. An object placed upon the top of a high building appears much less than when placed upon the ground at the same distance. When it stands upon the ground, the intervening tract of ground serves as a sign of its distance, and the distance, together with the visible magnitude, serves as a sign of its real magnitude. But when the object is placed on high, this sign of its distance is taken away. The remaining signs lead us to place it at a less distance, and this less distance, together with the visible magnitude, becomes a sign of a real less magnitude. The first two means we have mentioned would never of themselves make a visible object appear above 150 or 200 feet distant, because beyond that there is no sensible change either of the conformation of the eyes or of the inclination of their axes. The third mean is but a vague and undeterminate sign, when applied to distances above 200 or 300 feet, unless we know the real color and figure of the object. And the fifth mean, to be afterwards mentioned, can only be applied to objects which are familiar, or whose real magnitude is known. Hence it follows that when unknown objects upon or near the surface of the earth are perceived to be at the distance of some miles, it is always by this fourth mean that we are led to that conclusion. Dr. Smith hath observed very justly, that the known distance of the terrestrial objects which terminate our view, makes that part of the sky which is towards the horizon appear more distant than that which is toward the zenith. Hence it comes to pass, that the apparent figure of the sky is not that of a hemisphere, but rather a less segment of a sphere. And hence likewise it comes to pass that the diameter of the sun or moon, or the distance between two fixed stars, seen contiguous to a hill, or to any distant terrestrial object, appears much greater than when no such object strikes the eye at the same time. These observations have been sufficiently explained and confirmed by Dr. Smith. I beg leave to add, that when the visible horizon is terminated by very distant objects, the celestial vault seems to be enlarged in all its dimensions. When I view it from a confined street or lane, it bears some proportion to the buildings that surround me. But when I view it from a large plain, terminated on all hands by hills which rise one above another, to the distance of 20 miles from the eye, methinks I see a new heaven, whose magnificence declares the greatness of its author, and puts every human edifice at a countenance. For now the lofty spires and the gorgeous palaces shrink into nothing before it, and bear no more proportion to the celestial dome than their makers bear to its maker. 5. There remains another mean by which we perceive the distance of visible objects, and that is the diminution of their visible or apparent magnitude. By experience I know what figure a man, or any other known object, makes to my eye at the distance of 10 feet. I perceive the gradual and proportional diminution of this visible figure at the distance of 20, 40, 100 feet, and at greater distances, until it vanish altogether. Hence a certain visible magnitude of a known object becomes the sign of a certain determinate distance, and carries along with it the conception and belief of that distance. In this process of the mind, the sign is not a sensation, it is an original perception. We perceive the visible figure and visible magnitude of the object by the original powers of vision, but the visible figure is used only as a sign of the real figure, and the visible magnitude is used only as a sign of either the distance or of the real magnitude of the object, and therefore these original perceptions, like other mere signs, pass through the mind without any attention or reflection. This last mean of perceiving the distance of known objects serves to explain some very remarkable phenomena in optics, which would otherwise appear very mysterious. When we view objects of known dimensions through optical glasses, there is no other mean left of determining their distance, but this fifth. Hence it follows that known objects seen through glasses must seem to be brought nearer, in proportion to the magnifying power of the glass, or to be removed to a greater distance, in proportion to the diminishing power of the glass. If a man who had never before seen objects through a telescope were told that the telescope which he is about to use magnifies the diameter of the object 10 times, when he looks through this telescope at a man 6 feet high, what would he expect to see? Surely he would very naturally expect to see a giant 60 feet high. But he sees no such thing. The man appears no more than 6 feet high, and consequently no bigger than he really is, but he appears 10 times nearer than he is. The telescope indeed magnifies the image of this man upon the retina 10 times in diameter, and must therefore magnify his visible figure in the same proportion; and as we have been accustomed to see him of this visible magnitude, when he was 10 times nearer than he is presently, and in no other case, this visible magnitude, therefore, suggests the conception and belief of that distance of the object with which it hath been always connected. We have been accustomed to conceive this amplification of the visible figure of a known object only as the effect or sign of its being brought nearer, and we have annexed a certain determinate distance to every degree of visible magnitude of the object, and therefore any particular degree of visible magnitude, whether seen by the naked eye or by glasses, brings along with it the conception and belief of the distance which corresponds to it. This is the reason why a telescope seems not to magnify known objects, but to bring them nearer to the eye. When we look through a pinhole or a single microscope at an object which is half an inch from the eye, the picture of the object upon the retina is not enlarged, but only rendered distinct. Neither is the visible figure enlarged, yet the object appears to the eye 12 or 14 times more distant, and as many times larger in diameter than it really is. Such a telescope we have mentioned amplifies the image on the retina, and the visible figure of the object 10 times in diameter, and yet makes it seem no bigger, but only 10 times nearer. These appearances had been long observed by writers on optics. They tortured their invention to find the causes of them from optical principles, but in vain. They must be resolved into habits of perception, which are acquired by custom, but are apt to be mistaken for original perceptions. The Bishop of Cloyne first furnished the world with a proper key for opening up these mysterious appearances, but he made considerable mistakes in the application of it. Dr. Smith, in his elaborate and judicious treatise of optics, hath applied it to the apparent distance of objects seen with glasses, and to the apparent figure of the heavens, with such happy success, that there can be no more doubt about the causes of these phenomena. Section 23. Of the signs used in other acquired perceptions. The distance of objects from the eye is the most important lesson in vision. Many others are easily learned in consequence of it. The distance of the object, joined with its visible magnitude, is a sign of its real magnitude, and the distance of the several parts of an object, joined with its visible figure, becomes a sign of its real figure. Thus, when I look at a globe which stands before me, by the original powers of sight I perceive only something of a circular form, variously colored. The visible figure hath no distance from the eye, no convexity, nor hath it 3 dimensions. Even its length and breadth are incapable of being measured by inches, feet, or other linear measures. But when I have learned to perceive the distance of every part of this object from the eye, this perception gives it convexity, and a spherical figure, and adds a 3rd dimension to that which had but 2 before. The distance of the whole object makes me likewise perceive the real magnitude, for being accustomed to observe how an inch or a foot of length affects the eye at that distance, I plainly perceive by my eye the linear dimensions of the globe, and can affirm with certainty that its diameter is about 1 foot and 3 inches. It was shewn in the 7th section of this chapter that the visible figure of a body may, by mathematical reasoning, be inferred from its real figure, distance, and position with regard to the eye. In like manner we may, by mathematical reasoning, from the visible figure, together with the distance of the several parts of it from the eye, infer the real figure and position. But this last inference is not commonly made by mathematical reasoning, nor indeed by reasoning of any kind, but by custom. The original appearance which the color of an object makes to the eye is a sensation for which we have no name, because it is used merely as a sign, and is never made an object of attention in common life. But this appearance, according to the different circumstances, signifies various things. If a piece of cloth, of one uniform color, is laid so that part of it is in the sun and part in the shade, the appearance of color in these different parts is very different, yet we perceive the color to be the same. We interpret the variety of appearance as a sign of light and shade, and not as a sign of real difference in color. But if the eye could be so far deceived as not to perceive the difference of light in the 2 parts of the cloth, we should in that case interpret the variety of appearance to signify a variety of color in the parts of the cloth. Again, if we suppose a piece of cloth placed as before, but having the shaded part so much brighter in the color that it gives the same appearance to the eye as the more enlightened part, the sameness of appearance will here be interpreted to signify a variety of color, because we shall make allowance for the effect of light and shade. When the real color of an object is known, the appearance of it indicates, in some circumstances, the degree of light or shade. In others, the color of the circumambient bodies, whose rays are reflected by it. In other circumstances it indicates the distance or proximity of the object, as was observed in the last section. And by means of these many other things are suggested to the mind. Thus an unusual appearance in the color of familiar objects may be diagnostic of a disease in the spectator. The appearance of things in my room may indicate sunshine or cloudy weather, the earth covered with snow, or blackened with rain. It hath been observed that the color of the sky in a piece of painting may indicate the country of the painter, because the Italian sky is really of a different color from the Flemish. It was already observed that the original and acquired perceptions which we have by our senses are the language of nature to men, which in many respects has great affinity to human languages. The instances which we have given of acquired perceptions suggest this affinity, that as in human languages ambiguities are often found, so this language of nature, in our acquired perception, is not exempted from them. We have seen, in vision particularly, that the same appearance to the eye may, in different circumstances, indicate different things. Therefore, when the circumstances are unknown upon which the interpretation of the signs depends, their meaning must be ambiguous; and when the circumstances are mistaken, the meaning of the signs must also be mistaken. This is the case in all phenomena which we call fallacies of the senses, and particularly in those which are called fallacies in vision. The appearance of things to the eye always corresponds to the fixed laws of nature; therefore, if we speak properly, there is no fallacy in the senses. Nature always speaketh the same language, and useth the same signs in the same circumstances. But we sometimes mistake the meanings of the signs, either through ignorance of the laws of nature or through ignorance of the circumstances which attend the signs. To a man unacquainted with the principles of optics, almost every experiment that is made with the prism, with the magic lanthorn, with the telescope, with the microscope, seems to produce some fallacy in vision. Even the appearance of a common mirror, to one altogether unacquainted with the effects of it, would seem most remarkably fallacious. For, how can a man be more imposed upon than in seeing that before him which is really behind him? How can he be more imposed upon than in being made to see himself several yards removed from himself? Yet children, even before they can speak their mother tongue, learn not to be deceived by these appearances. These, as well as the other surprising appearances produced by optical glasses, are a part of the visual language, and to those who understand the laws of nature concerning light and colors, are in no wise fallacious, but have a distinct and true meaning. Chapter 6. Chapter 6, Part 7 of an Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by K. Hand. An Inquiry into the Human Mind on the Principles of Common Sense, by Thomas Reid. Chapter 6, Part 7. Section 24. Of the Analogy between Perception and the Credit we give to Human Testimony. The objects of human knowledge are innumerable, but the channels by which it is conveyed to the mind are few. Among these, the perception of external things by our senses, and the informations which we receive upon human testimony, are not the least considerable; and so remarkable is the analogy between these two, and the analogy between the principles of the mind which are subservient to the one, and those which are subservient to the other, without further apology, we shall consider them together. In the testimony of nature given by the senses, as well as in human testimony given by language, things are signified to us by signs; and in one, as well as the other, the mind, either by the original principles or by custom, passes from the sign to the conception and belief of the thing signified. We have distinguished our perceptions into original and acquired, and language into natural and artificial. Between acquired perception and artificial language there is a great analogy, but still a greater between original perception and natural language. The signs in original perception are sensations of which nature hath given us a great variety, suited to the variety of the things signified by them. Nature hath established a real connection between the signs and the things signified, and nature hath also taught us the interpretation of the signs, so that, previous to experience, the sign suggests the thing signified, and creates the belief of it. The signs in natural language are features of the face, gestures of the body, and modulations of the voice, the variety of which is suited to the variety of the things signified by them. Nature hath established a real connection between these signs and the thoughts and dispositions of the mind which are signified by them, and nature hath taught us the interpretation of the signs; so that, previous to experience, the signs suggest the thing signified and create the belief of it. A man in company, without doing good or evil, without uttering an articulate sound, may behave himself gracefully, civilly, politely; or, on the contrary, meanly, rudely, and impertinently. We see the dispositions of his mind, by their natural signs in his countenance and behaviour, in the same manner as we perceive the figure and other qualities of bodies by the sensations which nature hath connected with them. The signs in the natural language of the human countenance and behaviour, as well as the signs in our original perceptions, have the same signification in all climates, and in all nations, and the skill of interpreting them is not acquired but innate. In acquired perception the signs are either sensations, or things which we perceive by means of sensations. The connection between the sign and the thing signified is established by nature, and we discover this connection by experience, but not without the aid of our original perceptions, or of those which we have already acquired. After this connection is discovered, the sign, in like manner as in original perception, always suggests the thing signified and creates the belief of it. In artificial language the signs are articulate sounds, whose connection with the thing signified by them is established by the will of men; and in learning our mother tongue we discover this connection by experience, but not without the aid of natural language, or of what we had before attained of artificial language. And after this connection is discovered, the sign, as in natural language, always suggests the thing signified and creates the belief of it. Our original perceptions are few, compared with the acquired, but without the former we could not possibly attain the latter. In like manner, natural language is scanty, compared with artificial, but without the former we could not possibly attain the latter. Our original perceptions, as well as the natural language of human features and gestures, must be resolved into particular principles of the human constitution. Thus it is by one particular principle of our constitution that certain features express anger, and by another particular principle that certain features express benevolence. It is in like manner by one particular principle of our constitution that a certain sensation signifies hardness in the body which I handle, and it is by another particular principle that a certain sensation signifies motion in that body. But our acquired perceptions and the information we receive by means of artificial language must be resolved into general principles of the human constitution. When a painter perceives that this picture is the work of Raphael, that the work of Titian; a jeweller, that this is a true diamond, that a counterfeit; a sailor, that this is a ship of 500 ton, that of 400, these different acquired perceptions are produced by the same general principles of the human mind, which have a different operation in the same person, according as they are variously applied, and in different persons according to the diversity of their education and manner of life. In like manner, when certain articulate sounds convey to my mind the knowledge of the battle of Pharsalia, and others the knowledge of the battle of Pultola, when a Frenchman and an Englishman receive the same information by different articulate sounds, the signs used in these different cases produce the knowledge and belief of the thing signified, by the means of the same general principles of the human constitution. Now, if we compare the general principles of our constitution, which fit us for receiving information from our fellow creatures by language, with the general principles which fit us for acquiring the perception of things by our senses, we shall find them to be very similar in their nature and manner of operation. When we begin to learn our mother tongue, we perceive by the help of natural language that they who speak to us use certain sounds to express certain things; we imitate the same sounds when we would express the same things, and find that we are understood. But here a difficulty occurs which merits our attention, because the solution of it leads to some original principles of the human mind, which are of great importance and of very extensive influence. We know by experience that men have used such words to express things, but all experience is of the past, and can of itself give no notion or belief of what is future. How come we then to believe, and to rely upon it with assurance, that men who have it in their power to do otherwise will continue to use the same words when they think the same things? Whence comes this knowledge and belief, this foresight we ought rather to call it, of the future and voluntary actions of our fellow creatures? Have they promised that they will never impose upon us by equivocation or falsehood? No, they have not; and if they had, this would not solve the difficulty, for such promise must be expressed by words or by other signs, and before we can rely upon it, we must be assured that they put the usual meaning upon the signs which express that promise. No man of common sense ever thought of taking a man's own word for his honesty, and it is evident that we take his veracity for granted when we lay any stress upon his word or promise. I might add that this reliance upon the declarations and testimony of men is found in children long before they know what a promise is. There is, therefore, in the human mind an early anticipation, neither derived from experience, nor from reason, nor from any compact or promise, that our fellow creatures will use the same signs and language, when they have the same sentiment. This is, in reality, a kind of prescience of human actions, and it seems to me to be an original principle of the human constitution, without which we should be incapable of language, and consequently incapable of instruction. The wise and beneficent Author of nature, who intended that we should be social creatures, and that we should receive the greatest and most important part of our knowledge by the information of others, hath, for these purposes, implanted in our natures two principles that tally with each other. The first of these principles is, a propensity to speak truth, and to use the signs of language, so as to convey our real sentiments. This principle has a powerful operation, even in the greatest liars, for where they lie once, they speak truth 100 times. Truth is always uppermost, and is the natural issue of the mind. It requires no art or training, no inducement or temptation, but only that we yield to a natural impulse. Lying, on the contrary, is doing violence to our nature, and is never practiced, even by the worst men, without some temptation. Speaking truth is like using our natural food, which we would do from appetite, although it answered no end; but lying is like taking physic, which is nauseous to the taste, and which no man takes but for some end which he cannot otherwise attain. If it should be objected that men may be influenced by moral or political considerations to speak truth, and therefore that their doing so is no proof of such an original principle as we have mentioned, I answer, first, that moral or political considerations can have no influence, until we arrive at years of understanding and reflection. And it is certain from experience that children keep to truth invariably, before they are capable of being influenced by such considerations. Secondly, when we are influenced by moral or political considerations, we must be conscious of that influence, and capable of perceiving it upon reflection. Now, when I reflect upon my actions most attentively, I am not conscious that, in speaking truth, I am influenced on ordinary occasions by any motive moral or political. I find that truth is always at the door of my lips, and goes forth spontaneously if not held back. It requires neither good nor bad intention to bring it forth, but only that I be artless and undesigning. There may indeed be temptations to falsehood, which would be too strong for the natural principle of veracity, unaided by principles of honor or virtue; but where there is no such temptation, we speak truth by instinct, and this instinct is the principle I have been explaining. By this instinct a real connection is formed between our words and our thoughts, and thereby the former become fit to be signs of the latter, which they could not otherwise be. And although this connection is broken in every instance of lying and equivocation, yet these instances being comparatively few, the authority of human testimony is only weakened by them, but not destroyed. Another original principle implanted in us by the Supreme Being is a disposition to confide in the veracity of others, and to believe what they tell us. This is the counterpart to the former, and as that may be called the principle of veracity, we shall, for want of a more proper name, call this the principle of credulity. It is unlimited in children, until they meet with instances of deceit and falsehood, and it retains a very considerable degree of strength through life. If nature had left the mind of the speaker in equilibrio, without any inclination to the side of truth more than to that of falsehood, children would lie as often as they speak truth, until reason was so far ripened as to suggest the imprudence of lying, or conscience as to suggest its immorality. And if nature had left the mind of the hearer in equilibrio, without any inclination to the side of belief more than to that of disbelief, we should take no man's word until we had positive evidence that he spoke the truth. His testimony would, in this case, have no more authority than his dreams, which may be true or false, but no man is disposed to believe them on this account, that they were dreamed. It is evident that, in the matter of testimony, the balance of human judgment is by nature inclined to the side of belief, and turns to that side of itself, when there is nothing put to the opposite scale. If it was not so, no proposition that is uttered in discourse would be believed, until it was examined and tried by reason; and most men would be unable to find reasons for believing in the thousandth part of what is told them. Such distrust and incredulity would deprive us of the greatest benefits of society, and place us in a worse condition than that of savages. Children, on this supposition, would be absolutely incredulous, and therefore absolutely incapable of instruction. Those who had little knowledge of human life, and of the manner and characters of men, would be in the next degree incredulous; and the most credulous men would be those of the greatest experience and of deepest penetration, because in many cases they would be able to find good reason for believing testimony which the weak and ignorant could not discover. In a word, if credulity were the effect of reasoning and experience, it must grow up and gather strength, in the same proportion as reason and experience do. But, if it is the gift of nature, it will be strongest in childhood, and limited and restrained by experience. and the most superficial view of human life shews that the last is really the case, and not the first. It is the intention of nature that we should be carried in arms before we are able to walk upon our legs, and it is likewise the intention of nature that our belief should be guided by the authority and reason of others before it can be guided by our own reason. The weakness of the infant and the natural affection of the mother plainly indicate the former, and the natural credulity of youth and authority of age as plainly indicate the latter. The infant, by proper nursing and care, acquires strength to walk without support. Reason hath likewise her infancy, when she must be carried in arms; then she leans entirely upon authority, by natural instinct, as if she was conscious of her own weakness, and without this support she becomes vertiginous. When brought to maturity by proper culture, she begins to feel her own strength, and leans less upon the reason of others. She learns to suspect testimony in some cases, and to disbelieve it in others, and sets bounds to that authority to which she was at first entirely subject. But still, to the end of life, she finds a necessity of borrowing light from testimony where she has none within herself, and of leaning in some degree upon the reason of others where she is conscious of her own imbecility. And as in many instances, reason, even in her maturity, borrows aid from testimony, so in others she mutually gives aid to it and strengthens its authority. For as we find good reason to reject testimony in some cases, so in others we find good reason to rely upon it with perfect security in our most important concerns. The character, the number, and the disinterestedness of witnesses, the impossibility of collusion, and the incredibility of their concurring in testimony without collusion, may give an irresistible strength to testimony, compared to which its native and intrinsic authority is very inconsiderable. Having now considered the general principles of the human mind which fit us for receiving information from our fellow creatures by the means of language, let us next consider the general principles which fit us for receiving the information of nature by our acquired perceptions. It is undeniable, and indeed is acknowledged by all, that when we have found two things to have been constantly conjoined in the course of nature, the appearance of one of them is immediately followed by the conception and belief of the other. The former becomes the natural sign of the latter, and the knowledge of their constant conjunction in time past, whether got by experience or otherwise, is sufficient to make us rely with assurance upon the continuance of that conjunction. This process of the human mind is so familiar that we never think of inquiring into the principles on which it is founded. We are apt to conceive it as self-evident truth, that what is to come must be similar to what is past. Thus, if a certain degree of cold water freezes to day, and has been known to do so in all time past, we have no doubt but the same degree of cold will freeze water to morrow, or a year hence. That is a truth which all men believe as soon as they understand it, I readily admit. But the question is, whence does its evidence arise? Not from comparing the ideas, surely. For when I compare the idea of cold with that of water hardened into a transparent solid body, I can perceive no connection between them. No man can show the one to be the necessary effect of the other. No man can give a shadow of reason why nature hath conjoined them. But do we not learn their conjunction from experience? True. Experience informs us that they have been conjoined in time past. But no man ever had any experience as what is future. And this is the very question to be resolved: how we come to believe that the future will be like the past. Hath the Author of nature promised this? Or were we admitted to his counsel when he established the present laws of nature and determined the time of their continuance? No, surely. Indeed, if we believe that there is a wise and good Author of nature, we may see a good reason why he should continue the same laws of nature and the same connections of things for a long time. Because if he did otherwise, we could learn nothing from what is past, and all our experience would be of no use to us. But though this consideration, when we come to the use of reason, may confirm our belief of the continuance of the present course of nature, it is certain that it did not give rise to this belief; for children and idiots have this belief as soon as they know that fire will burn them. It must therefore be the effect of instinct, not of reason. The wise Author of our nature intended, that a great and necessary part of our knowledge should be derived from experience, before we are capable of reasoning, and he hath provided means perfectly adequate to this intention. For first, he governs nature by fixed laws, so that we find innumerable connections of things which continue from age to age. Without this stability of the course of nature there could be no experience, or it would be a false guide, and lead us into error and mischief. If there were not a principle of veracity in the human mind, men's words would not be signs of their thoughts; and if there were no regularity in the course of nature, no one thing could be a natural sign of another. Secondly, he hath implanted in human minds an original principle by which we believe and expect the continuance of the course of nature, and the continuance of these connections which we have observed in times past. It is by this general principle of our nature that when two things have been found connected in time past, the appearance of the one produces the belief of the other. I think the ingenious author of the Treatise of Human Nature first observed, that our belief of the continuance of the laws of nature cannot be founded either upon knowledge or probability. But, far from conceiving it to be an original principle of the mind, he endeavours to account for it from his favourite hypothesis, that belief is nothing but a certain degree of vivacity in the idea of the thing believed. I made a remark upon this curious hypothesis in the second chapter, and shall now make another. The belief which we have in perception is a belief of the present existence of the object. That which we have in memory is a belief of its past existence. The belief of which we are now speaking is a belief of its future existence, and in imagination there is no belief at all. Now, I would gladly know of this author, how one degree of vivacity fixes the existence of the object to the present moment, another carries it back to time past, a third, taking a contrary direction, carries it into futurity, and a fourth carries it out of existence altogether. Suppose, for instance, that I see the sun rising out of the sea. I remember to have seen him rise yesterday. I believe he will rise to-morrow, near the same place. I can likewise imagine him rising in that place, without any belief at all. Now, according to this sceptical hypothesis, this perception, this memory, this foreknowledge, and this imagination are all the same idea, diversified only by different degrees of vivacity. The perception of the sun rising is the most lively idea. The memory of his rising yesterday is the same idea, a little more faint. The belief of his rising to-morrow is the same idea, yet fainter. And the imagination of his rising is still the same idea, but faintest of all. One is apt to think that this idea might gradually pass through all possible degrees of vivacity without stirring out of its place. But if we think so, we deceive ourselves, for no sooner does it begin to grow languid than it moves backwards into time past. Supposing this to be granted, we expect at least that as it moves backward by the decay of its vivacity, the more that vivacity decays, it will go back the farther, until it remove quite out of sight. But here we are deceived again, for there is a certain period of this declining vivacity, when, as if it had met an elastic obstacle in its motion backward, it suddenly rebounds from the past to the future, without taking the present into its way. And now, having got into the regions of futurity, we are apt to think that it has room enough to spend all its remaining vigour. But still we are deceived, for by another sprightly bound it mounts up into the airy region of imagination. So that ideas, in the gradual declination of their vivacity, seem to imitate the inflection of verbs and grammar. They begin with the present, and proceed in order to the preterite, the future, and the indefinite. This article of the Sceptical Creed is indeed so full of mystery, on whatever side we view it, that they who hold that creed are very injuriously charged with incredulity. For to me it appears to require as much faith as that of St. Athanasius. However, we agree with the author of the Treatise of Human Nature in this, that our belief of the continuance of nature's laws is not derived from reason. It is an instinctive prescience of the operations of nature, very like to that prescience of human actions which makes us rely upon the testimony of our fellow creatures. And as, without the latter, we should be incapable of receiving information from men by language, so, without the former, we should be incapable of receiving the information of nature by means of experience. All our knowledge of nature beyond our original perceptions is got by experience, and consists in the interpretation of natural signs. The constancy of nature's laws connects the sign with the thing signified, and by the natural principle just now explained, we rely upon the continuance of the connections which experience hath discovered, and thus the appearance of the sign is followed by the belief of the thing signified. Upon this principle of our constitution, not only acquired perception, but all inductive reasoning, and our reasoning from analogy, is grounded, and therefore, for want of another name, we shall beg leave to call it the inductive principle. It is from the force of this principle that we immediately assent to that axiom built upon which all our knowledge of nature is built, that effects of the same kind must have the same cause. For effects and causes in the operations of nature mean nothing but signs, and the things signified by them. We perceive no proper causality or efficiency in any natural cause, but only a connection established by the course of nature between it and what is called its effect. Antecedently to all reasoning, we have by our constitution an anticipation that there is a fixed and steady course of nature, and we have an eager desire to discover this course of nature. We attend to every conjunction of things which presents itself, and expect the continuance of that conjunction. And when such a conjunction has been often observed, we conceive the things to be naturally connected, and the appearance of one without any reasoning or reflection carries along with it the belief of the other. If any reader should imagine that the inductive principle may be resolved into what philosophers usually call the association of ideas, let him observe, natural signs are not associated with the idea only, but with the belief of the thing signified. Now, this can with no propriety be called an association of ideas, unless ideas and belief be one and the same thing. A child has found the prick of a pin conjoined with pain; hence he believes and knows that these things are naturally connected; he knows that the one will always follow the other. If any man will call this only an association of ideas, I dispute not about words, but I think he speaks very improperly. For if we express it in plain English, it is a prescience, that things which he hath found conjoined in time past will be conjoined in time to come. And this prescience is not of the effect of reasoning, but of an original principle of human nature, which I have called the inductive principle. This principle, like that of credulity, is unlimited in infancy, and gradually restrained and regulated as we grow up. It leads us often into mistakes, but is of infinite advantage upon the whole. By it the child once burnt shuns the fire; by it he likewise runs away from the surgeon by whom he was inoculated. It is better that he should do the last, than that he should not do the first. But the mistakes we are led into by these two natural principles are of a different kind. Men sometimes lead us into mistakes, when we perfectly understand their language, by speaking lies. But nature never misleads us in this way; her language is always true, and it is only by misinterpreting it that we fall into error. There must be many accidental conjunctions of things, as well as natural connections, and the former are apt to be mistaken for the latter. Thus, in the instance above mentioned, the child connected the pain of inoculation with the surgeon, whereas it really was connected with the incision only. Philosophers and men of science are not exempted from such mistakes; indeed all false reasoning in philosophy is owing to them. It is drawn from experience and analogy, as well as reasoning, otherwise it could have no verisimilitude. But the one is an unskilful and rash, the other a just and legitimate, interpretation of natural signs. If a child or a man of common understanding were put to interpret a book of science wrote in his mother tongue, how many blunders and mistakes would he be apt to fall into! Yet he knows as much of this language as is necessary for his manner of life. The language of nature is the universal study, and the students are of different classes. Brutes, idiots, and children employ themselves in this study, and owe to it all their acquired perceptions. Men of common understanding make a greater progress, and learn, by a small degree of reflection, many things of which children are ignorant. Philosophers fill up the highest form in this school, and are critics in the language of nature. All these different classes have one teacher, experience, enlightened by the inductive principle. Take away the light of this inductive principle, and experience is as blind as a mole. She may indeed feel what is present, and what immediately touches her, but she sees nothing that is either before or behind, upon the right hand or upon the left, future or past. The rules of inductive reasoning, or of a just interpretation of nature, as well as the fallacies by which we are apt to misinterpret her language, have been, with wonderful sagacity, delineated by that great genius of Lord Bacon, so that his Novum Organum may justly be called a grammar of the language of nature. It adds greatly to the merit of this work, and atones for its deficits, that at the time it was written the world had not seen any tolerable model of inductive reasoning, from which the rules of it might be copied. The arts of poetry and eloquence were grown up to perfection when Aristotle described them, but the art of interpreting nature was yet in embryo when Bacon delineated its manly features and proportions. Aristotle drew his rules from the best models of those arts that have yet appeared, but the best models of inductive reasoning that have yet appeared, which I take to be the third book of Principia and the Optics of Newton, were drawn from Bacon's rules. The purpose of all those rules is to teach us to distinguish seeming or apparent connections of things in the course of nature from such as are real. They that are unskilful in inductive reasoning are more apt to fall into error in their reasonings from the phenomena of nature than in their acquired perceptions; because we often reason from a few mistakes, and thereby are apt to mistake accidental conjunctions of things for natural connections. But that habit of passing, without reasoning, from the sign to the thing signified, which constitutes acquired perception, must be learned by many instances or experiments, and the number of experiments serves to disjoin those things which have been accidentally conjoined, as well as to confirm our belief of natural connections. From the time that children begin to use their hands, nature directs them to handle everything over and over, to look at it while they handle it, and to put it in various positions, and at various distances from the eye. We are apt to excuse this as a childish diversion, because they must be doing something, and have not reason to entertain themselves in a more manly way. But if we think more justly, we shall find that they are engaged in the most serious and important study, and if they had all the reason of a philosopher, they could not be more properly employed. For it is this childish employment that enables them to make the proper use of their eyes. They are thereby every day acquiring habits of perception, which are of greater importance than anything we can teach them. The original perceptions which nature gave them are few, and insufficient for the purposes of life, and therefore she made them capable of acquiring many more perceptions by habit. And to complete her work she hath given them an unwearied assiduity in applying to the exercises by which those perceptions are acquired. This is the education which nature gives to her children. And since we have fallen upon this subject, we may add that another part of nature's education is, that by the course of things children must often exert all their muscular force, and employ all their ingenuity, in order to gratify their curiosity and satisfy their little appetites. What they desire is only to be obtained at the expense of labor and patience, and many disappointments. By the exercise of body and mind necessary for satisfying their desires, they acquire agility, strength, and dexterity in their motions, as well as health and vigor to their constitutions. They learn patience and perseverance. They learn to bear pain without dejection, and disappointment without despondence. The education of nature is most perfect in savages, who have no other tutor; and we see that, in the quickness of all their senses, in the agility of all their motions, in the hardiness of their constitutions, and in the strength of their minds, to bear hunger, thirst, pain, and disappointment, they commonly far exceed the civilized. A most ingenious writer on this account seems to prefer the savage life to that of society. But the education of nature could never of itself produce a Rousseau. It is the intention of nature that human education should be joined to her institution in order to form the man. And she hath fitted us for human education by the natural principles of imitation and credulity, which discover themselves almost in infancy, as well as by others which are of later growth. When the education which we receive from men does not give scope to the education of nature, it is wrong directed; it tends to hurt our faculties of perception, and to enervate both the body and mind. Nature hath her way of rearing men, as she hath of curing their diseases. The art of medicine is to follow nature, to imitate and to assist her in the cure of diseases; and the art of education is to follow nature, to assist and imitate her in the way of rearing men. The ancient inhabitants of the Balears followed nature in the manner of teaching their children to be good archers, when they hung their dinner aloft by a thread, and left the younkers to bring it down by their skill in archery. The education of nature, without any more human care than is necessary to preserve life, makes a perfect savage. Human education, joined to that of nature, may make a good citizen, a skilful artisan, or a well-bred man. But reason and reflection must superadd their tutory, in order to produce a Rousseau, a Bacon, or a Newton. Notwithstanding the innumerable errors committed in human education, there is hardly any education so bad as to be worse than none. And I apprehend that even if Rousseau were to choose whether to educate a son among the French, the Italians, the Chinese, or the Eskimos, he would not give preference to the last. When reason is properly employed, she will confirm the documents of nature, which are always true and wholesome; she will distinguish, in the documents of human education, the good from the bad, rejecting the last with modesty, and adhering to the first with reverence. Most men continue all their days to be just what nature and human education made them. Their manners, their opinions, their virtues, and their vices are all got by habit, imitation, and instruction; and reason has little or no share in forming them. Chapter 7 of an Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by K. Hand. An Inquiry into the Human Mind on the Principles of Common Sense, by Thomas Reid. Chapter 7. Conclusion. Containing reflections upon the opinions of philosophers on this subject. There are two ways in which men may form their notions and opinions concerning the mind and concerning its powers and operations. The first is the only way that leads to truth, but it is narrow and rugged, and few have entered upon it. The second is broad and smooth, and hath been much beaten, not only by the vulgar, but even by philosophers. It is sufficient for common life, and is well adapted to the purposes of the poet and orator; but in philosophical disquisitions concerning the mind, it leads to error and delusion. We may call the first of these ways the way of reflection. When the operations of the mind are exerted, we are conscious of them, and it is in our power to attend to them, and to reflect upon them, until they become familiar objects of thought. This is the only way in which we can form just and accurate notions of those operations. But this attention and reflection is so difficult to man, surrounded on all hands by external objects, which constantly solicit his attention, that it has been very little practised, even by philosophers. In the course of this inquiry, we have had many occasions to show how little attention hath been given to the most familiar operations of the senses. The second and most common way in which men form their opinions concerning the mind and its operations we may call the way of analogy. There is nothing in the course of nature so singular, but we can find some resemblance, or at least some analogy, between it and other things with which we are acquainted. The mind naturally delights in hunting after such analogies, and attends to them with pleasure. From them poetry and wit derive a greater part of their charms, and eloquence not a little of its persuasive force. Besides the pleasure we receive from analogies, they are of very considerable use, both to facilitate the conception of things, when they are not easily apprehended without such a handle, and to lead us to probable conjectures about their nature and qualities, when we want the means of more direct and immediate knowledge. When I consider that the planet Jupiter, in like manner as the Earth, rolls around its own axis and revolves around the Sun, and that he is enlightened by several secondary planets, as the Earth is enlightened by the Moon, I am apt to conjecture from analogy that as the Earth by these means is fitted to be the habitation of various orders of animals, so the planet Jupiter is, by the like means, fitted for the same purpose, and have no argument more direct and conclusive to determine me in this point, I yield to this analogical reasoning a degree of assent proportioned to its strength. When I observe that the potato plant very much resembles the solanum in its flower and fructification, and am informed that the last is poisonous, I am apt from analogy to have some suspicion of the former. But in this case I have access to more direct and certain evidences, and therefore ought not to trust analogy, which would lead me in error. Arguments from analogy are always at hand, and grow up spontaneously in a fruitful imagination, while arguments that are more direct and more conclusive often require painful attention and application, and therefore mankind in general have been very much disposed to trust the former. If one attentively examines the systems of the ancient philosophers, either concerning the material world or concerning the mind, he will find them to be built solely upon the foundation of analogy. Lord Bacon first delineated the strict and severe method of induction. Since his time it has been applied with very happy success in some parts of natural philosophy, and hardly in anything else. But there is no subject in which mankind are so much disposed to trust to the analogical way of thinking and reasoning, as in what concerns the mind and its operations; because, to form clear and distinct notions of those operations in the direct and proper way, and to reason about them, requires a habit of attentive reflection of which few are capable, and which, even by these few, cannot be attained without much pains and labour. Every man is apt to form his notions of things difficult to be apprehended, or less familiar, from their analogy to things which are more familiar. Thus, if a man bred to the seafaring life, and accustomed to think and talk only of matters relating to navigation, enters into discourse upon any other subject, it is well known that the language and notions proper to his own profession are infused into every subject, and all things are measured by the rules of navigation. And if he should take it into his head to philosophize concerning the faculties of the mind, it cannot be doubted but he would draw his notions from the fabric of his ship, and would find in the mind sails, masts, rudder, and compass. Sensible objects of one kind or another do no less occupy and engross the rest of mankind than things relating to navigation the seafaring man. For a considerable part of life we can think of nothing but the objects of sense, and to attend to objects of another nature, so as to form clear and distinct notions of them, is no easy matter, even after we come to years of reflection. The condition of mankind, therefore, affords good reason to apprehend that their language and their common notions concerning the mind and its operations will be analogical, and derived from the objects of sense; and that these analogies will be apt to impose upon philosophers, as well upon the vulgar, and to lead them to materialize the mind and its faculties. And experience abundantly confirms the truth of this. How generally men of all nations and in all ages of the world have conceived the soul, or thinking principle in man, to be some subtle matter, like breath or wind, the names given to it in almost all languages sufficiently testify. We have words which are proper, and not analogical, to express the various ways in which we perceive external objects by the senses, such as feeling, sight, taste; but we are often obliged to use these words analogically, to express either powers of the mind which are of a very different nature. And the powers which imply some degree of reflection have generally no names but such as are analogical. The objects of thought are said to be in the mind, to be apprehended, comprehended, conceived, imagined, retained, weighed, ruminated. It does not appear that the notions of the ancient philosophers with regard to the nature of the soul were much more refined than those of the vulgar, or that they were formed in any other way. We shall distinguish the philosophy that regards our subject into the old and the new. The old reached down to Descartes, who gave it a fatal blow, of which it has been gradually expiring ever since, and is now almost extinct. Descartes is the father of the new philosophy that relates to the subject, but it hath been gradually improving since his time, upon the principles laid down by him. The old philosophy seems to have been purely analogical. The new is more derived from reflection, but still with a very considerable mixture of the old analogical notions. Because the objects of sense consist of matter and form, the ancient philosophers conceived every thing to belong to one of these, or to be made up of both. Some therefore thought that the soul is a particular kind of subtle matter, separable from our gross bodies; others thought that it is only a particular form of the body, and inseparable from it. For there seem to have been some among the ancients, as well as some among the moderns, who conceive that a certain structure or organization of the body is all that is necessary to render it sensible and intelligent. The different powers of the mind were, accordingly, by the last sect of philosophers, conceived to belong to different parts of the body, as the heart, the brain, the liver, the stomach, the blood. They who thought that the soul is a subtle matter separable from the body disputed to which of the four elements it belongs, whether to earth, water, air, or fire. Of the three last, each had its particular advocates, but some were of the opinion that it partakes of all the elements, that it must have something in its composition similar to everything we perceive, and that we perceive earth by the earthly part, water by the watery part, and fire by the fiery part of the soul. Some philosophers, not satisfied with the determining of what kind of matter the soul is made, inquired likewise into its figure, which they determined to be spherical, that it might be the more fit for motion. The most spiritual and sublime notion concerning the nature of the soul to be met with among the ancient philosophers I conceive to be that of the Platonists, who held that it is made of that celestial and incorruptible matter of which the fixed stars were made, and therefore has a natural tendency to rejoin its proper element. I am at a loss to say in which of these classes of philosophers Aristotle ought to be placed. He defines the soul to be the first entelechia of a natural body which has potential life. I beg to be excused from translating the Greek word because I know not the meaning of it. The notions of the ancient philosophers with regard to the operations of the mind, particularly with regard to perceptions and ideas, seem likewise to have been formed by the same kind of analogy. Plato, of the writers that are extant, first introduced the word idea into philosophy, but his doctrine upon this subject had somewhat peculiar. He agreed with the rest of the ancient philosophers in this, that all things consist of matter and form, and that the matter of which all things were made existed from eternity without form; but he likewise believed that there are eternal forms of all possible things which exist without matter, and to these eternal and immaterial forms he gave the name of ideas, maintaining that they are the only object of true knowledge. It is of no great moment to us whether he borrowed these notions from Parmenides, or whether they were the issue of his own creative imagination. The latter Platonists seem to have improved upon them, in conceiving those ideas, or external forms of things, to exist, not of themselves, but in the divine mind, and to be the models and patterns according to which all things were made. Then lived the Eternal One, then deep retired in his unfathomed essence, viewed at large the uncreated images of things. To these Platonic notions that of Malebranche is very nearly allied. This author seems, more than any other, to have been aware of the difficulties attending to the common hypothesis concerning ideas, to wit, that ideas of all objects of thought are in the human mind, and therefore, in order to avoid those difficulties, makes the ideas which are the immediate objects of human thought to be the ideas of things in the divine mind, who, being intimately present to every human mind, may discover his ideas to it as far as pleaseth him. The Platonists and the Malebranche excepted, all other philosophers, as far as I know, have conceived that there are ideas or images of every object of thought in the human mind, or at least in some part of the brain, where the mind is supposed to have its residence. Aristotle had no good affection to the word idea, and seldom or never uses it but in refuting Plato's notions about ideas. He thought that matter may exist without form, but that form cannot exist without matter. But at the same time he taught that there can be no sensation, no imagination, nor intellection without forms, phantasms, or species in the mind, and that things sensible are perceived by sensible species, and things intelligible by intelligible species. His followers taught more explicitly that those sensible and intelligible species are set forth by the objects, and make their impressions upon the passive intellect, and that the active intellect perceives them in the passive intellect. And this seems to have been the common opinion while the peripatetic philosophy retained its authority. The Epicurean doctrine, as explained by Lucretius, though widely different from the peripatetic in many things, is almost the same in this. He reaffirms that slender films or ghosts, tenua rerum simulacra, are still going off from all things and flying about, and that these being extremely subtle, easily penetrate our gross bodies, and striking upon the mind cause thought and imagination. After the peripatetic system had reigned above 1,000 years in the schools of Europe, almost without a rival, it sunk before that of Descartes, the perspicuity of whose writings and notions, contrasted with the obscurity of Aristotle and his commentators, created a strong prejudice in favor of this new philosophy. The characteristic of Plato's genius was sublimity, that of Aristotle's subtlety, but Descartes far excelled in both perspicuity, and bequeathed this spirit to his successors. The system which is now generally received with regard to the mind and its operations derives not only its spirit from Descartes, but its fundamental principles, and after all the improvements made by Malebranche, Locke, Berkeley, and Hume, may still be called the Cartesian system. We shall therefore make some remarks upon its spirit and tendency in general, and upon its doctrine concerning ideas in particular. It may be observed that the method which Descartes pursued naturally led him to attend more to the operations of the mind by accurate reflection, and to trust less to analogical reasoning upon this subject, than any philosopher had done before him. Intending to build a system upon a new foundation, he began with the resolution to admit nothing but what was absolutely certain and evident. He supposed that his senses, his memory, his reason, and every other faculty to which we trust in common life, might be fallacious, and resolved to disbelieve everything, until he was compelled by irresistible evidence to yield assent. In this method of proceeding, what appeared to him first of all certain and evident was, that he thought, that he doubted, that he deliberated. In a word, the operations of his own mind, of which he was conscious, must be real, and no delusion; and though all his other faculties should deceive him, his consciousness could not. This therefore he looked upon as the first of all truths. This was the first firm ground upon which he set his foot, after being tossed in the ocean of scepticism, and he resolved to build all knowledge upon it, without seeking after any more first principles. As every other truth, therefore, and particularly the existence of the objects of sense, was to be deduced by a train of strict argumentation from what he knew by consciousness, he was naturally led to give attention to the operations of which he was conscious, without borrowing his notions of them from external things. It was not in the way of analogy, but attentive reflection, that he was led to observe that thought, volition, remembrance, and the other attributes of the mind are altogether unlike to extension, to figure, and to all other attributes of the body; and that we have no reason, therefore, to conceive thinking substances to have any resemblance to extended substances; and that, as the attributes of thinking substance are things of which we are conscious, we may have a more certain and immediate knowledge of them by reflection, than we can have of external objects by our senses. These observations, as far as I know, were first made by Descartes, and they are of more importance, and throw more light upon the subject, than all that had been said upon it before. They ought to make us diffident and jealous of every notion concerning the mind and its operations, which is drawn from sensible objects in the way of analogy, and to make us rely only upon accurate reflection as the source of all real knowledge upon this subject. 2. I observe that as the peripatetic system has a tendency to materialize in the mind and its operations, so the Cartesian has a tendency to spiritualize body and its qualities. One error common to both systems leads to the first of these extremes in the way of analogy, and to the last in the way of reflection. The error I mean is, that we can know nothing about body or its qualities but as far as we have sensations which resemble those qualities. Both systems agreed in this, but according to their different methods of reasoning they drew very different conclusions from it. The peripatetic drawing his notions of sensation from the qualities of body; the Cartesian, on the contrary, drawing his notions of the qualities of body from his sensations. The peripatetic, taking it for granted that bodies and their qualities do really exist, and are such as we commonly take them to be, inferred from them the nature of his sensations, and reasoned in this manner: Our sensations are the impressions which sensible objects make upon the mind, and may be compared to the impression of a seal upon wax. The impression is the image or form of the seal, without the matter of it. In like manner, every sensation is the image or form of some sensible quality of the object. This is the reasoning of Aristotle, and it has an evident tendency to materialize the mind and its sensations. The Cartesian, on the contrary, thinks that the existence of body, or of any of its qualities, is not to be taken as a first principle, and that we ought to admit nothing concerning it but what, by just reasoning, can be deduced from our sensations. And he knows that by reflection we can form clear and distinct notions of our sensations, without borrowing our notions of them by analogy from the objects of sense. The Cartesians, therefore, beginning to give attention to their sensations, first discovered that the sensations corresponding to secondary qualities cannot resemble any quality of the body. Hence Descartes and Locke inferred that sound, taste, smell, color, heat, and cold, which the vulgar took to be qualities of the body, were not qualities of body, but of mere sensations of the mind. Afterward, the ingenious Berkeley, considering more attentively the nature of sensation in general, discovered and demonstrated that no sensation whatever could possibly resemble any quality of an insentient being, such as a body is supposed to be; and hence he inferred, very justly, that there is the same reason to hold extension, figure, and all the primary qualities to be mere sensations, as there is to hold the secondary qualities to be mere sensations. Thus, by just reasoning upon the Cartesian principles, matter was stripped of all its qualities. The new system, by a kind of metaphysical sublimation, converted all the qualities of matter into sensations, and spiritualized body, as the old had materialized spirit. The way to avoid both these extremes is, to admit the existence of what we see and feel as a first principle, as well as the existence of things whereof we are conscious, and to take our notions of the qualities of body from the testimony of our senses, with the Peripatetics, and our notions of our sensations from the testimony of consciousness, with the Cartesians. 3. I observed that the modern skepticism is the natural issue of the new system, and that, although it did not bring forth this monster into the year 1739, it may be said to have carried it in its womb from the beginning. The old system admitted all the principles of common sense as first principles, without requiring any proof of them; and therefore, though its reasoning was commonly vague, analogical, and dark, yet it was built upon a broad foundation, and had no tendency to skepticism. We do not find that any Peripatetic thought it incumbent upon him to prove the existence of a material world, but every writer upon the Cartesian system attempted this, until Berkeley clearly demonstrated the futility of their arguments, and thence concluded that there was no such thing as a material world, and that the belief of it ought to be rejected as a vulgar error. The new system admits only of the principles of common sense as the first principle, and pretends, by strict augmentation, to deduce all the rest from it. That our thoughts, our sensations, and everything of which we are conscious hath a real existence, is admitted in this system as a first principle, but everything else must be made evident by the light of reason. Reason must rear the whole fabric of knowledge upon this single principle of consciousness. There is a disposition in human nature to reduce things to as few principles as possible, and this, without doubt, adds to the beauty of a system, if the principles are able to support what rests upon them. The mathematicians glory, very justly, in having raised so noble and magnificent a system of science upon the foundation of a few axioms and definitions. This love of simplicity, of reducing things to few principles, hath produced many a false system; but there never was any system in which it appears so remarkably as that of Descartes. His whole system concerning matter and spirit is built upon one axiom, expressed in one word, cogito. Upon the foundation of conscious thought, with ideas for his materials, he builds his system of human understanding, and attempts to account for all its phenomena. And having, as he imagined from his consciousness, proved the existence of matter and of a certain quantity of motion originally impressed upon it, he builds his system of the material world, and attempts to account for all its phenomena. These principles, with regard to the material system, have been found insufficient, and it has been made evident that besides matter and motion we must admit gravitation, cohesion, corpuscular attraction, magnetism, and other centripetal and centrifugal forces, by which the particles of matter attract and repel each other. Newton, having discovered this and demonstrated that these principles cannot be resolved into matter and motion, was led by analogy and the love of simplicity to conjecture, but with a modesty and caution peculiar to him, that all the phenomena of the material world depended upon attracting and repelling forces in the particles of matter. But we may now venture to say that this conjecture fell short of the mark; for even in the unorganized kingdom, the powers by which salts, crystals, spars, and many other bodies concrete into regular forms, can never be accounted for by attracting and repelling forces in the particles of matter. And in the vegetable and animal kingdoms there are strong indications of powers of a different nature from all the powers of unorganized bodies. We see, then, that although in the structure of the material world there is, without a doubt, all the beautiful simplicity consistent with the purposes for which it was made, it is not so simple as the great Descartes determined it to be; nay, it is not so simple as the greater Newton modestly conjectured it to be. Both were misled by analogy and the love of simplicity. One had been much conversant about the extension, figure, and motion; the other had enlarged his views to attracting and repelling forces; and both formed their notions of unknown parts of nature from those with which they were acquainted, as the shepherd Tityrus formed his notion of the city of Rome from his country village. Urbem quam dicunt Romam melibae putabi, stultus ego huic nostre similem, quo saepe solemus pastores oveum teneros depellere fatus, sic canibus catulos similes, sic matribus aidos, noram, sic parvis componere magna solebam. This is just a picture of the analogical way of thinking. But to come to the system of Descartes concerning the human understanding, it was built, as we have observed, upon consciousness as its sole foundation, and with ideas as its materials, and all his followers have built upon the same foundation and with the same materials. They acknowledge that nature hath given us various simple ideas. These are analogous to the matter of Descartes' physical system. They acknowledge likewise a natural power by which ideas are compounded, disjoined, associated, compared. This is analogous to the original quantity of motion in Descartes' physical system. From these principles they attempt to explain the phenomena of the human understanding, just as in the physical system the phenomena of nature were to be explained by matter and motion. It must indeed be acknowledged that there is great simplicity in this system as well as in the other. There is such a similitude between the two as may be expected between children of the same father; but as the one has been found to be the child of Descartes, and not of nature, there is ground to think that the other is so likewise. That the natural issue of this system is skepticism with regard to everything except the existence of our ideas, and of their necessary relations, which appear upon comparing them, is evident. For ideas being the only objects of thought, and having no existence but when we are conscious of them, it necessarily follows that there is no object of our thought which can have a continued and permanent existence. Body and spirit, cause and effect, time and space, to which we were wont to ascribe an existence independent of our thought, are all turned out of existence by this short dilemma. Either these things are ideas of sensation or reflection, or they are not. If they are ideas of sensation or reflection, they can have no existence but when we are conscious of them. If they are not ideas of sensation or reflection, they are words without any meaning. Neither Descartes nor Locke perceived this consequence of their system concerning ideas. Bishop Berkeley was the first who discovered it. And what followed upon this discovery? Why, with regard to the material world, and with regard to space and time, he admits the consequence, that these things are mere ideas, and have no existence but in our minds. But with regard to the existence of spirits or minds, he does not admit the consequence; and if he had admitted it, he must have been an absolute skeptic. But how does he evade this consequence with regard to the existence of spirits? The expedient which the good bishop uses on this occasion is very remarkable, and shows his great aversion to skepticism. He maintains that we have no ideas of spirits, and that we can think and speak and reason about them, and about their attributes, without having any ideas of them. If this is so, my lord, what should hinder us from thinking and reasoning about bodies and their qualities, without having ideas of them? The bishop either did not think of this question, nor did think fit to give any answer to it. However, we may observe that in order to avoid skepticism he fairly starts out of the Cartesian system, without giving any reason why he did so in this instance and in no other. This indeed is the only instance of a deviation from Cartesian principles which I have met with in the successors of Descartes, and it seems to have been only a sudden start occasioned by the terror of skepticism, for in all other things Berkeley's system is founded upon Cartesian principles. Thus we see that Descartes and Locke take the road that leads to skepticism, without knowing the end of it, but they stop short for want of light to carry them farther. Berkeley, frightened at the appearance of the dreadful abyss, starts aside and avoids it. But the author of the Treatise of Human Nature, more daring and intrepid, without turning aside to the right hand or to the left, like Virgil's Alecto, shoots directly into the gulf. Hic species horrendum et saevi spiracula ditis, monstrantur ruptoque ingens ercerante vorago pestiferas apert fauces. 4. We may observe that the account given by the new system of that furniture of the human understanding which is the gift of nature, and not the acquisition of our own reasoning faculty, is extremely lame and imperfect. The natural furniture of the human understanding is of two kinds: first, the notions or simple apprehensions which we have of things; and secondly, the judgments, or the belief which we have concerning them. As to our notions, the new system reduces them to two classes: ideas of sensation and ideas of reflection. The first are conceived to be copies of our sensations, retained in the memory or imagination; the second to be copies of the operations of our minds, whereof we are conscious, in like manner retained in the memory or imagination; and we are taught that these two comprehend all the materials about which the human understanding is or can be employed. As to our judgment of things, or the belief which we have concerning them, the new system allows no part of it to be the gift of nature, but holds it to be the acquisition of reason, and to be got by comparing our ideas and perceiving their agreements or disagreements. Now I take this account, both of our notions and of our judgments or belief, to be extremely imperfect, and I shall briefly point out some of its capital defects. The division of our notions into ideas of sensation and ideas of reflection is contrary to all rules of logic, because the second member of the division includes the first. For, can we form clear and just notions of our sensations any other way than by reflection? Surely we cannot. Sensation is an operation of the mind of which we are conscious, and we get the notion of sensation by reflecting upon that which we are conscious of. In like manner, doubting and believing are operations of the mind whereof we are conscious; we get the notion of them by reflecting upon what we are conscious of. The ideas of sensation, therefore, are ideas of reflection, as much as the ideas of doubt or believing, or any other ideas whatsoever. But to pass over the inaccuracy of this division, it is extremely incomplete. For since sensation is an operation of the mind as well as all the other things of which we form our notions by reflection, when it is asserted that all our notions are either ideas of sensation or ideas of reflection, the plain English of this is, that mankind neither do nor can think of anything but of the operations of their own mind. Nothing can be more contrary to truth, or more contrary to the experience of mankind. I know that Locke, while he maintained this doctrine, believed the notions which we have of body and of its qualities, and the notions which we have of motion and of space, to be the ideas of sensation. But why did he believe this? Because he believed those notions to be nothing else but images of our sensations. If therefore the notions of body and its qualities, of motion and space, be not images of our sensations, will it not follow that those notions are not ideas of sensation? Most certainly. There is no doctrine in the new system which more directly leads to skepticism than this. And the author of the Treatise of Human Nature knew very well how to use it for that purpose. For if you maintain that there is any such existence as body or spirit, time or place, cause or effect, he immediately catches you between the horns of this dilemma. Your notions of these existences are either ideas of sensation or ideas of reflection. If of sensation, from what sensation are they copied? If of reflection, from what operations of the mind are they copied? It is indeed to be wished that those who have written much about sensation, and about the other operations of the mind, had likewise thought and reflected much, and with great care, upon those operations. But is it not very strange that they will not allow it to be possible for mankind to think of anything else? The account which this system gives of our judgment and belief concerning things is as far from the truth as the account it gives of our notions or simple apprehensions. It represents our senses as having no other office but that of furnishing the mind with notions or simple apprehensions of things, and makes our judgment and belief concerning those things to be acquired by comparing our notions together and perceiving their agreements or disagreements. We have shown, on the contrary, that every operation of the senses in its very nature implies judgment or belief as well as simple apprehension. Thus, when I feel the pain of the gout in my toe, I have not only a notion of pain, but a belief of its existence, and a belief of some disorder in my toe which occasions it; and this belief is not produced by comparing ideas and perceiving their agreements and disagreements; it is included in the very nature of the sensation. When I perceive a tree before me, my faculty of seeing gives me not only a notion or simple apprehension of the tree, but a belief of its existence, and of its figure, distance, and magnitude; and this judgment or belief is not got by comparing ideas; it is included in the very nature of the perception. We have taken notice of several original principles of belief in the course of this inquiry, and when other faculties of the mind are examined, we shall find more, which have not occurred in the examination of the five senses. Such original and natural judgments are therefore a part of that furniture which nature hath given to the human understanding. They are the inspiration of the Almighty, no less than our notions or simple apprehensions. They serve to direct us in the common affairs of life where our reasoning faculty would leave us in the dark. They are a part of our constitution, and all the discoveries of our reason are grounded upon them. They make up what is called the common sense of mankind, and what is manifestly contrary to any of those first principles is what we call absurd. The strength of them is good sense, which is often found in those who are not acute in reasoning. A remarkable deviation from them, arising from a disorder in the constitution, is what we call lunacy, as when a man believes that he is made of glass. When a man suffers himself to be reasoned out of the principles of common sense by metaphysical arguments, we may call this metaphysical lunacy, which differs from the other species of the distemper in this, that it is not continued, but intermittent. It is apt to seize the patient in solitary and speculative moments, but when he enters into society, common sense recovers her authority. A clear explication and enumeration of the principles of common sense is one of the chief desiderata in logic. We have only considered such of them as occurred in the examination of the five senses. 5. The last observation that I shall make upon the new system is, that although it professes to set out in the way of reflection and not of analogy, it hath retained some of the old analogical notions concerning the operations of the mind, particularly, that things which do not exist in the mind itself can only be perceived, remembered, or imagined, by means of ideas or images of them in the mind, which are the immediate objects of perception, remembrance, and imagination. This doctrine appears evidently to be borrowed from the old system, which taught that external things make impressions upon the mind, like the impressions of a seal upon wax; that it is by means of those impressions that we perceive, remember, or imagine them; and that those impressions must resemble the things from which they are taken. When we form our notions of the operations of the mind by analogy, this way of conceiving them seems to be very natural, and offers itself to our thoughts. For as everything which is felt must make some impression upon the body, we are apt to think that everything which is understood must make some impression upon the mind. From such analogical reasoning, this opinion of the existence of ideas or images of things in the mind seems to have taken its rise, and to have been so universally received among philosophers. It was observed already that Berkeley, in one instance, apostatizes from this principle of the new system, by affirming that we have no ideas of spirits, and that we can think of them immediately without ideas. But I know not whether in this he has had any followers. There is some difference likewise among modern philosophers with regard to the ideas or images by which we perceive, remember, or imagine sensible things. For though all agree in the existence of such images, they differ about their place, some placing them in a particular part of the brain, where the soul is thought to have her residence, and others placing them in the mind itself. Descartes held the first of these opinions, to which Newton seems likewise to have inclined; for he proposes this query in his Optics: Anon sensorium animalum est locus qui substantia sentiens adest, en quim sensibilis rerum species per nervos et cerebrum desferuntur, ut ibi praesentes a praesente sentire possint. But Locke seems to place the ideas of sensible things in the mind; and that Berkeley and the author of the Treatise of Human Nature were of the same opinion is evident. The last makes a very curious application of this doctrine, by endeavoring to prove from it that the mind either is no substance, or that it is an extended and divisible substance, because the ideas of extension cannot be in a subject which is indivisible and unextended. I confess I think his reasoning in this, as in most cases, is clear and strong. For whether the idea of extension be only another name for extension itself, as Berkeley and his author assert, or whether the idea of extension be an image and resemblance of extension, as Locke conceived, I appeal to any man of common sense whether extension, or any image of extension, can be in an unextended and indivisible object. But while I agree with him in his reasoning, I would make a different application of it. He takes it for granted that there are ideas of extension in the mind, and thence infers that if it is at all a substance, it must be an extended and divisible substance. On the contrary, I take it for granted, upon the testimony of common sense, that my mind is a substance, that is, a permanent subject of thought; and my reason convinces me that it is an unextended and indivisible substance, and hence I infer that there cannot be in it anything that resembles extension. If this reasoning had occurred to Berkeley, it would probably have led him to acknowledge that we may think and reason concerning bodies without having ideas of them in the mind, as well as concerning spirits. I intended to have examined more particularly and fully this doctrine of the existence of ideas or images of things in the mind, and likewise another doctrine which is founded upon it, to wit, that judgment or belief is nothing but a perception of the agreement or disagreement of our ideas; but having already shewn, through the course of this inquiry, that the operations of the mind which we have examined give no countenance to either of these doctrines, and in many things contradict them, I have thought it proper to drop this part of my design. It may be educated with more advantage, if it is at all necessary, after inquiring into some other powers of the human understanding. Although we have examined only the five senses and the principles of the human mind which are employed about them, or such as have fallen in our way in the course of this examination, we shall leave the further prosecution of this inquiry to future deliberation. The powers of memory, of imagination, of taste, of reasoning, of moral perception, the will, the passions, the affections, and all the active powers of the soul, present a vast and boundless field of philosophical disquisition, which the author of this inquiry is far from thinking himself able to survey with accuracy. Many authors of ingenuity, ancient and modern, have made excursions into this vast territory, and have communicated useful observations. But there is reason to believe that those who have pretended to give us a map of the whole have satisfied themselves with a very inaccurate and incomplete survey. If Galileo had attempted a complete system of natural philosophy, he had, probably, done little service to mankind. But by confining himself to what was within his comprehension, he laid the foundation of a system of knowledge which rises by degrees and does honor to the human understanding. Newton, building upon this foundation, and in like manner confining his inquiries to the law of gravitation and the properties of light, performed wonders. If he had attempted a great deal more, he had done a great deal less, and perhaps nothing at all. Ambitious of following such great examples with unequal steps, alas, and unequal force, we have attempted an inquiry only into one little corner of the human mind, that corner which seems to be most exposed to vulgar observation, and to be most easily comprehended. And yet, if we have delineated it justly, it must be acknowledged that the accounts heretofore given of it were very lame, and wide of the truth. The End. End of Chapter 7. End of an Inquiry into the Human Mind on the Principles of Common Sense, by Thomas Reid.